All right, we are recording. Hi, everyone. Welcome to the day 3 of the Forge Online Bootcamp. My name is Petr Broz. I'm a Forge developer advocate. Some of you may remember me from the previous days. Some of you probably worked with my colleague Adam, using the .NET Core or .NET version of our tutorials. Today, we're going to put the server-side development aside, and we're going to focus on the client side. So we're basically joining both groups together. Today, we have a shared webinar for both Node.js and .NET developers today, because it doesn't really matter what kind of Forge application you're running on the server side. Today, we're going to be customizing our viewer. All right. So again, very quickly, what this event is about. It's basically our way to help you, to guide you through the tutorials on the LearnForge website, right? So again, we provide many different learning resources. We developer advocates, and we do acknowledge that some of our customers, some of the developers getting started with the Forge development prefer a more interactive and guided approach to learning this technology other than just following a LearnForge tutorial on their own. That's why we provide these events. Again, the way this works is every day we choose one of the tutorials from the LearnForge website. Today, we're going to be looking at the viewer customizations, extensions, and dashboards. And we basically live code through that tutorial with you, right? So each webinar is split into 4 sessions, where at the beginning of the session, we live code through some part of the tutorial, and then we give you some time to follow our steps and follow along, right? And then let's say 2 hours later, we meet again, we go through another part of the tutorial, and we again give you some time to follow our steps and implement the same piece of functionality, where at the end of the day, we end up with a complete Forge application. All right. Again, the topic for today, for Wednesday, is the customization of the viewer and showing you different ways of extracting information from your models using the viewer APIs and using that information to build any kind of customized dashboard experience. And again, while the previous 2 days were really where we provided 2 parallel tracks for .NET version and Node.js version, today, it doesn't really matter which language you use for the server side. You can use any of the applications that were built on Monday and Tuesday in any of the programming languages that you chose, right? Today, it doesn't really matter. As long as you can get your application running, what we're going to be doing today, we're just going to be customizing the client side, which is really just the HTML, a little bit of CSS, and the client side JavaScript, right? So that is really shared no matter what language, what programming language you're using on the server side. All right. These are the applications that we're going to be building today. So as you can see, we're going to see how we can extend the viewer, add some custom functionality to it, add some extra UI elements like new buttons in the toolbar, create our custom panels that maybe show some special summary data information that we may need to compute or provide to the user of our application, right? Or how we can start building dashboards with charts based on certain data extracted from our Forge designs using the viewer APIs. All right. How we're going to proceed today in the first session right now, we're going to make sure that we're all leveled, that we're all at the, hopefully the same, in the same state, or to make sure that everybody has some kind of Forge application that they can run so that we can later start modifying it in the subsequent sessions. And again, make sure that you have some kind of code editor available and some Node.js or .NET runtime. But again, we expect, or we hope that most of you joining us today have already gone through day one or day two. So we're assuming that you already have one of the Forge applications from the Learn Forge website available, up and running. But if not, don't worry, we'll also provide some tips on where you can get these applications. In session 2, we're going to start enhancing our viewer. We're going to start by building a basic viewer extension, right? Because we provide the viewer, Forge Viewer provides a way to wrap your custom viewer functionality into these reusable units we call extensions. And we're going to see how you can start handling different events in the viewer, for example, selection change. In session 3, we're going to take a look at how you can customize the UI of the viewer, how you can add your custom visual panels to show your custom data. And we're going to start extracting information from our models for the final session, session 4, where we're going to start adding the dashboards and charts, right? So in the final session, we're going to adjust the HTML layout of our application a little bit. And we're going to add some charts with, again, representing some summary data calculated from our design properties. All right, let's start with session 1. And again, before we do that, just again quick note on the organization here, logistics. All the sessions this week are recorded and will be shared with you after the event, when we'll be sending out a close-up email to all of you. We're going to make sure that you get all the links to these recordings on YouTube. And also, as I'm going through these slides and through the demos, if you have any questions, feel free to ask in the Q&A or in the chat. I'll try and monitor these as I proceed, or even in those breaks in between the different sessions. If you have any questions, feel free to use this Zoom feature, the Q&A. And again, we want to make sure that you can run through the different tutorials smoothly without any issues. All right. So again, very quickly, we again expect that most of you have gone through these steps on the day 1 or day 2. But if you are joining us here for the first time today, let's just, there's a couple of things we need to make sure that you have available before we can start coding. And that is, you should have access to Forge. So you should have an account and be able to log into the forge.autodesk.com website. If you don't have an account there, that's fine. You can create one for free and you'll get a Forge subscription trial, which is valid for, I believe, 3 months. I do already have my account, so I'm just going to sign in here. And then once you're logged into the Forge developer portal, we will ask you to go to, in your profile, to go to My Apps. This is where you will basically manage all your different Forge applications. And what Forge apps are, again, I was explaining that in the previous webinars. A Forge app is, very simply put, just sort of a username and password for your custom application that you'll be using to authenticate to Forge whenever you want Forge to do something for you, right? So when you create your Forge application, we will generate a client ID and client secret for that app. That's, again, that's sort of like the app's username and password. And whenever you're building your Forge app, you will need to use these two values, the client ID and client secret, to start communicating with Forge, to authenticate, to generate an access token that can then be used to upload files, translate files, get a list of projects in BIM 360, or any operations, really, any interaction with Forge will require some kind of an access token that will be generated with these credentials. Okay, so if you don't have your application yet, just hit the Create Add button. I don't think there's any limit to how many you can have. So just create an app, let's say for this week, right, for our Bootcamp event. And here I already created mine on Monday. I called it Online Bootcamp September 2021. and I already have my client ID and client secret available here. So again, make sure that if you haven't created your Forge app before, make sure that you have one. Again, as for the other parameters, they don't really matter as much. The callback URL would matter if you remember from the day 2, if you were building an app where you want to allow your users to log in, right? To maybe be redirected to Autodesk servers, log in, maybe provide a consent that they allow your application to access their data in, again, BIM 360 or ACC perhaps. So then when they do provide the consent, Autodesk needs to know where it should redirect them to after, right? Later. So the callback URL is where you would specify this address. This should typically be some endpoint on your own server application that can then receive the information from Autodesk and generate an access token for that particular user. All right, so again, for now, I think for today, I'm going to be using the simple application from day 1. That's just the app where you don't need to log in or anything, where you simply have a bucket where you can upload your files and view them. So that's what I'm going to be using today. But again, you're free to use the application for day 2 from day 2 as well if you want. And again, it doesn't matter at all whether you build your app in Node.js or .Net or even any other languages that we offer on the LearnForge website. Right? Today we're just going to be tweaking the client-side JavaScript code and the HTML a little bit. All right. That is for our Forge app. Now, if you are working with Node.js, again, just make sure that you have the Node.js runtime installed. If not, you can get it from nodejs.org, and we recommend installing the long-term support version. That should be version 14. And you can find the version that you have available locally by simply going to your command line. And again, on macOS, I'm using a standard terminal with bash. On Windows, you can use the command prompt, or if you have Git installed, you could use bash that is installed with Git on Windows. Right? I wouldn't recommend using PowerShell because we have some experience with PowerShell behaving differently in some aspects. So sometimes people were having problems when they tried following our tutorials using PowerShell. So I do not recommend using that one, at least not for today. All right. Now, so if you're a Node.js developer, if you want to quickly check the version of your Node.js runtime, in your terminal, simply execute this command, node-v. Right, so you can see I have Node.js version 14.17 installed on my machine, so I'm good to go. This should all the Node.js installer should also install npm, the package manager. So if I type npm-v, I see that okay, I have npm available as well, specifically version 6.14. All right, and in terms of a code editor, again, this is totally up to you. Right, we recommend if you're looking for a suggestion, we recommend trying the Visual Studio Code editor again. And Visual Studio Code is this sort of like smaller brother of the proper full-blown Visual Studio. I think it cannot do. I don't think it can do as much as full-blown Visual Studio, but it also makes it faster and pretty easy and nice to work with. It's really good for web development, I believe, and it's cross-platform, so you can run it on different operating systems. So Visual Studio is what I'm going to be using here today. But again, you can use proper Visual Studio, you can use IntelliJ, you can use WebStorm, whichever code editor you like the most. Here, in my case, I'm going to be using VS Code. All right. Now, if you're a .NET developer, if you've been following our webinars on Monday or Tuesday, you have most likely been using the Visual Studio Community Edition. So feel free to use that one today as well. And again, to make sure that you can actually run one of the sample applications that we were building on Monday and Tuesday, just make sure that you have the ASP.NET and web development workload and the .NET desktop development workload as well. I mean, this one may not be strictly necessary for today. I think this one is really going to be important for tomorrow, for the final topic of the online bootcamp this week, which is going to be the use of the design automation service in Forge. All right, so again, feel free to use Visual Studio with your .NET version of the Forge apps that we were building on Monday or Tuesday, or in other words, applications that the first two tutorials on the Learn Forge website, right? So view your models. This is the tutorial. This is the sample app we were building on Monday. View BIM 360 Fusion models. This is the app we were building on Tuesday. So any of these, if you already have available, it's perfect. You can just use that one for today, as we're going to be improving or customizing the viewer side of things. Now, for those of you who maybe, again, haven't built any sample app on Monday or Tuesday, that's totally fine as well, because on the Learn Forge website, we actually provide a complete implementation of the different samples in different programming languages. So for example, if we look at the first tutorial, view your models, you will see that at the end, we already provide a complete ready-to-use implementation of that sample app for different programming languages, right? So if you're a Node.js developer, you can simply head over to this link, and that'll take you to a GitHub repository, to a specific branch that contains the complete implementation of the sample from the first tutorial, right? Or if you prefer .NET Core or Go or PHP or Java, you can grab these as well, right? For these other languages, or I mean, for any of these really, all you need to do is just follow the README files, the README markdown file, to make sure that you have your app set up properly, right? Really the important thing is going to be setting the Forge client ID and Forge client secret environment variables, so that your application, when you run it, can receive it from the environment and use the client ID and client secret to start communicating with Forge. So just in case, again, any of you are in this situation, I'm going to try and get a copy of, let's say, this Node.js version of the code on my machine and prepare it so that in session 2, I can start using it and I can start tweaking the viewer, the client side JavaScript logic. And again, if you prefer .NET and you don't have your application for Monday or Tuesday available, simply grab one of these. Now, to actually get the source code, you have a couple of options. If you have Git installed on your machine, you can clone the repository to your local file system, right? Now, if you don't have Git, you might actually as well just get it, because it's a free tool and it's pretty useful, especially when you start, when you deal with web development, and lots of projects are available on GitHub, so you may want to clone them, right? So if you don't have Git installed, I'd recommend that you can simply Google Git, and you'll find this gitscm.com page. This is the official page of the source control management tool of Git, right? And you can download it from here. You can download it for your specific platform. And again, if you're on Windows, I believe that Git should actually install Bash, the sort of like Unix-like command line interface as well, which is also kind of nifty to have on Windows, because again, then you have a consistent environment like we do here. All right, so you can install Git there, and then in my case, I do have Git available already. So again, if I type git -- version, you see I'm running on version 2.30. So that's one option, right? So I could go ahead and basically follow the README steps in this GitHub repository. So this is, again, the Node.js version of the sample from the first tutorial, right? And I could run this command to clone the Node.js branch from this GitHub repository to my machine, right? Let me actually try and do that. I go to my command line. So again, I'm cloning this specific GitHub repository and the Node.js branch from it to my folder here. And that's it. And if I take a look here, I have the Learn Forge View Models. That's the name of the GitHub repository with the Node.js code available in there, right? That's one way. Now, if you don't feel like installing Git now, that's fine. You don't have to. You can simply, because on GitHub, you have the option of basically, instead of cloning the code to your machine, you can simply download a zip file with all the source code in there. Okay, so that's another option. I can go to I can save the zip file to my machine and extract it. And again, I have the same Node.js source code here, right? So let's say this is going to be the app, the sample app that I'm going to be using today, right? In the subsequent sessions when we start customizing the viewer. All right. That's for source code app. Now, again, when you follow this route, right, and you'll need to set up or provide Forge client ID and client secret to your application in a certain way, right? And this may be slightly different for the Node.js application and for the .NET or Java or Go application. But here, again, all you need to do if you need to grab a working version of a project of the sample code from the Learn Forge website, you just follow the README, right? So here we explain, okay, how you can grab the copy, a copy of this implementation, and then depending on what system you're on, right, how you can actually install dependencies, because again, .NET and Node.js and Go have their own way of installing dependencies, of course, and how you can provide the environment variables that the application will need, right? So in my case, if I were to go to my sample code, this is the source code that I just unzipped from GitHub, right? If I were to run this, let's say the start file, it won't work because it cannot find the dependency for this project, right? So first thing we need to do is install dependencies. So for Node.js, that'll be through npm install. And again, for .NET or .NET Core, that might be different, right? So just follow the README, because for .NET Core, I believe you would need to call .NET Restore, I believe. That's what basically downloads and installs all the .NET dependencies that your .NET project is using. All right, so now we have our dependencies installed. So now I could maybe start the app, but now if I try and run it again, it still fails, right? It says, I can't find any Forge client ID, Forge client secret environment variables, right? So one thing I could do is I could, because I'm on Mac OS, I'm on Unix-based system, using Bash, I would use this syntax, right? I'm using the export command to define some new environment variables. So I'm going to define one called Forge client ID, and I'm going to set it to the client ID of my application. And then I can say, define another environment variable called Forge client secret. I can set it to the client secret. All right. Now, just to repeat what I was saying on Monday and Tuesday, it's definitely not a good idea to share your client secret with anyone. I have to share it here because, again, I'm sharing my screen for you, right? But what I'm going to do after the event, I'm basically going to hit this regenerate button on the Forge portal to have Forge generate a new client secret for this particular application. But yeah, you don't want to share it with anyone, of course, because then they could just start communicating with Forge on your behalf and start accessing potentially your users' data, which wouldn't be good. All right, so now we should have a Forge client ID and client secret defined. So now if I try running the application, now it runs, right? Now it's ready on port 3000, because again, in this case, I'm using Node.js. When you're going to be using, if you're using .NET or .NET Core, the app might be running on a different port. Again, this is going to be specific to the language that you want to work with. All right, so if I go to localhost 3000, you can see I have my basic HTML layout. This is the sample basic application from the first tutorial on the Learn Forge website. And hopefully, it hasn't been translated yet. So I'm going to translate the sports car. There we go. All right, so I have my app ready for the session 2 when we are actually going to start customizing the viewer here. All right. And that is it for the first session. Now, maybe a quick shameless plug for those of you who maybe worked with Adam on Monday and Tuesday, who haven't used Visual Studio. Maybe if you're considering using Visual Studio, one thing I like to mention is if you decide to give Visual Studio a try, we provide a Forge extension for it, actually, something that you can use to access your Forge data and the different Forge functionality directly from the editor, right? So here, if you head over to the extensions, and you look for Autodesk Forge, you'll find the Autodesk Forge Tools extension. And then when you install it, it'll appear here in the sidebar with the Forge icon. And when you run it for the first time, it'll ask you to enter some Forge application client ID and client secret. Again, that's your app's credentials, right? Because the tool, the extension itself also needs some way to authenticate itself to the Forge servers. So that's why, again, we recommend that you can just enter the client ID and client secret of one of your apps. You can later add additional environments and switch between them using the status bar at the bottom, right? Let me see, I can actually do that right now. If I go to settings in VS Code and search for Forge, you'll see that there is an option called Forge environments. This one is it's a piece of JSON, so you have to edit it directly inside the Visual Studio Code settings, which is itself a JSON file, right? So I already have some Forge application here, an old one, probably one from day 1 or day 2. So what I'm going to do is I'm going to grab the credentials of my Forge app that I'm going to be using today, and I'm going to paste it here. All right, that's it. So I have my first Forge environment I just called my env defined here. And now if I reload VS Code, you'll see that now I'm able to see the same bucket and the same data I was able to see from my custom application, right, from localhost. So it's the same sports car DWFX. And I had already translated it so I can see the one output that was generated for me by the Forge Model Derivative Service. And I can even right click. I can right click all the different elements in the extension sidebar and to get access to different functionalities. I can upload objects to buckets. I can, I don't know, download or delete objects or get their manifest from the Model Derivative Service. Right, that would be done here. For example, view object manifest JSON. This under the hood makes a request to the Forge Model Derivative Service to get, this JSON that tells us about the different outputs that the Model Derivative Service was able to extract for this particular design. Right, so this says that the translation is complete, and that it's been able to extract something, some thumbnails, some 3D view, well, one 3D view, that's the one we actually see here, called Autodesk Car, right? And potentially some other information. Now you can even right-click one of the outputs of the Model Derivative Service and preview it here in Visual Studio Code. right? So you don't need to write any code, and you can immediately just start browsing through your content in Forge, upload new files, translate them from here, etc. So again, if you're not using Visual Studio Code and you are thinking about maybe giving it a try, this might be one more argument why it might be worth it. Then it might also be helpful for tomorrow because, like I said earlier, in the Thursday class, you're going to be working with the Forge Design Automation service, and you can access that service here as well, right? So apart from the standard buckets and model derivatives, you can also access stuff like your Forge webhooks. You can manage them, create new webhooks or edit existing ones. And you can also work with the design automation content, right? So you'll be learning about something called add bundles and design automation activities, and you can also list and create and manage all these from this editor environment as well. So you can see that even though I haven't really created any add bundles of my own or any design automation activities of my own, I can already see some shared ones, right? Again, by right-clicking, I can get access to additional actions. So in this case, if I need to see some details about a specific design automation add bundle, I can just right-click it and get the info there. If I want to maybe see this one, this activity, I can see what kind of inputs it takes, what kinds of outputs it generates, etc., etc. All right. That is it for our first session for my part of the demo. And now it's your turn. So again, when we meet back here in roughly 1 hour and 30 minutes, let's make sure that you have your Forge account, that you can log into Forge with at least the trial subscription. Let's make sure that you have a Forge application ready with client ID and client secret. And let's make sure that you have one of the applications from Monday or Tuesday up and running on your machine. So again, if you have already joined us in one of the previous days, you most likely have that app available and running already. If not, you can simply head back to the Learn Forge website, right? And grab, let's say, the complete sample for the first tutorial, do your models for any of the programming languages that you prefer. Right. And again, just make sure that, for example, when you choose .NET Core, right, when you grab this version of the source code and clone it to your machine or download the zip, right, just make sure to follow the README file, because again, for different programming languages, there may be slightly different instructions how to get your application up and running. Right. So for .NET Core, you may need to, again, take a slightly different approach to install dependencies for that project before you can run it, right? Let's see if I use the .NET Framework version of our sample app. There you'll see that, for example, in this case, we're specifying the Forge client ID and the Forge client secret in this web.config file instead of specifying environment variables. All right. So that's it. And if you have any questions in the meantime, before we see you back here in 1.5 hours, feel free to submit your questions. I see that there are already some, so I'm going to go through these now, and I'll try and monitor the Q&A even again in this break, right? So if you have any problem, don't hesitate and ask away. All right. So first question, is the Forge extension for .NET Core .NET Framework in Visual Studio? Unfortunately not. So I'm sure that Visual Studio provides some way to build custom extensions for it as well, but I'm not familiar with those, right? I'm spending most of my time using Visual Studio Code, and at one point I kind of started wondering that, I was curious, how difficult would it be to add my custom extension for this editor, right? Because I saw there were plenty, right? Microsoft is developing its own for like Azure stuff. You have some official Docker extensions, really a lot of different Visual Studio Code extensions available here. So I was wondering how difficult it would be to try and add my own, right? And since I'm spending most of my time developing in JavaScript and TypeScript, right? And the Visual Studio Code editor is actually implemented in TypeScript. So it was really, really easy for me to build this piece of functionality, right? And again, for Visual Studio, I'm not aware of any similar extension like this that I don't think anyone has developed anything like this for the proper Visual Studio, unfortunately. But so, I mean, in that case, if you prefer working with, using Visual Studio for development, you could still do that, right? And you could maybe just use VS Code just for the extension to browse your content in Forge. Might be an option. And then I see one more. Is there any video or demo on how to use the Forge extension? I believe so, yes. Let me check. Take a look at the GitHub repo, because by the way, I mean, the implementation of the Forge extension itself is available on GitHub as well. And I think I may have included a link, or maybe not. Yeah, there are just a couple of short animations showing how to use the different features of the extension, but I think they're maybe not here. I thought I added a video as well, but it's in here. Maybe it was on Forge blog. So let me try something. Autodesk Forge blog, VS Code. So this is one option. So I wrote a blog post about how to use Forge from within Visual Studio Code. So again, you'll find more information on the blog. So you can simply Google Autodesk Forge blog VS Code. And I noticed when I Googled for these phrase keywords that it actually found a lightning talk that we did, which it also talks about how to use Forge from Visual Studio Code. So you can actually find a complete video. It's like 14-minute video on YouTube. That might have been as well. Yeah, okay, so this is me as well, presenting how, so this is the video I was looking for. Yeah, so you'll find it on YouTube as well. Just Google for Autodesk Forge VS Code. All right. Now, one more question. What are the advantages and disadvantages of using .NET Framework versus .NET Core in Forge apps? That's a good question. I don't really think there are any major advantages or disadvantages. I think it's really mostly about the language that you're most comfortable with, right? We do provide the Forge SDKs for both, but I guess personally, I kind of like .NET Core more, but that's only my subjective opinion because I'm more on the Node.js side of things. So I kind of like this easy way to start building your server apps, which compared to standard .NET, that was very different, right? Like building your first ASP.NET app, there's a lot of scaffolding and a lot of wiring, a lot of stuff that you need to do just to get a simple server application, which in Node.js is just a couple lines of code, right? So now I think, Microsoft is sort of like chasing Node.js in that aspect. And I've been following it closely with, all the new syntax they're adding to C# and with all the new features they're adding to .NET Core, right? So I'm really a big fan of the .NET 6, right? And now .NET 6, I don't know if you've seen it, but this is pretty neat and something I'm exploring as well. .NET 6 has something, or I believe this was introduced in version 6 or maybe 5. I think it was in .NET 6. They have something called Minimal API. If you haven't seen it, just Google .NET 6 Minimal API. This is pretty neat. So again, this is, in my opinion, this is basically Microsoft chasing this ease of use, right? And they're trying to match Node.js in how easy it is to build a simple server application, right? So let's see. I mean, take a look at this, right? This is a new way in .NET 6 to build a server application that handles the requests to the index URL with responding with hello world. So there are no controllers, there are no startup CS object, no program CS object, there are no web configs, there are, you know, none of that bulk is there. It's like, this is kind of like them, you know, chasing after Node.js, allowing you to build an app like this simple. So this is something I'm actually exploring for. So I've been working on the side on like a sort of a new version of the Learn Forge tutorials, because I believe that there's a way to make them much simpler and, you know, less code to grok, right, and to understand, to dig through, and that they can be really modernized and simplified. So I've been working on this new version of these, and I've been exploring the use of this .NET 6 minimal API as well. All right, and one more question. In the docking panel on-click function, could you provide a side example explaining the computing of data like short an array of objects? Okay, I think we could probably do that when we get to that point. I definitely want to, you know, make this a little more interactive. So when we get to when we start building the, you know, docking panel or start implementing some part of it, like extracting data from the models using the viewer APIs, definitely ask questions as we go through the demos. And again, I'm hoping that we can make this a little more interactive, so we can maybe diverge slightly from the code that's actually provided by the Learn Forge website, and maybe see if we can customize it or change it, and maybe, you know, provide a better alternative for it. So definitely. So please remind me as we get to that point. I think that's the topic of the session 3. All right. And one more question. Can I load a 3D model from BIM 360 as SVF2? Yes, okay. All right. So for those of you who don't know, SVF2 is this relatively new format, output format, offered by the model derivative service. Let me go to the documentation. Let's take a look at the model derivative service here. Right, so the model derivative service is meant, its main purpose is to extract all sorts of information from your models, right? Thumbnails, 3D models, 2D drawings, metadata, logical hierarchies, etc. Now, typically, for a long time, the model derivative service would only offer this SVF format on the output, right? So it can ingest over 60 different file formats here, even our competitors, right? Like SolidWorks assembly, SolidWorks parts. But for a long time, it would only offer SVF1, SVF as the output. This is a proprietary format called, it stands for Streamable Viewing Format. And it's used by Forge Viewer, right? So whenever you take your Revit or SolidWorks or Inventor or AutoCAD drawing file, you send it to Forge, we can translate it into this SVF, and the SVF format can then be viewed in Forge Viewer. And this has been used for a long time, this worked for a long time, but then we really started to see the need for a more optimized version, streamed version using WebSockets and, you know, adding a lot of deduplication, because when there were a lot of duplicate geometry, the SVF files could easily explode in size. So SVF2 works much better in that sense. And the SVF2 format has been used in BIM 360 for some time, even before we made the SVF2 format available to Forge developers. But I think the situation around BIM 360 is a little bit more complex, because BIM 360 has been using this optimized file format, but using different servers. So it wasn't even called SVF2, it was using a different code name. So basically all that is to say, I'm not sure if you can get an SVF2 file from BIM 360, because when you upload your designs to BIM 360, they will be automatically translated at no additional cost, right? That the translation is covered by the BIM 360 subscription. But I believe they're still translated into this intermediate format, not SVF2 exactly, right? And you can actually find that, and I'll show that when we get to the viewer development. You can actually, there is a method in the viewer APIs that you can use to check whether a model is SVF1 or SVF2, or whether it's this temporary format that was used by BIM 360. It was called OTG. So I'll explain that when we start messing around with viewer APIs. All right. Tracking element properties change between models. Okay. So if I understand correctly, this question is basically asking how would one go about comparing changes between two versions of a model? I'm guessing that's the question. So when it comes to like changes in, let's say, the structure of a design, because like I mentioned a couple seconds ago, right, the model derivative service, one of the things it exports is the logical hierarchy of your model, right? Okay, so if you are interested in tracking changes in those logical hierarchies, we do actually provide a viewer extension for that. And it's the same logic that BIM 360 is using. If you Google Autodesk Div extension, I believe, Div extension. Yeah, that will hopefully you'll find a blog post from May 2020, last year, that was written by my colleague Chardon. And this basically shows you how you can already use an extension, because as I mentioned, right, today in the upcoming sessions, we're going to be talking about customizing the viewer and building all sorts of viewer extensions. There are actually many different extensions available for the viewer already, and one of them is called the Autodesk Div Tool. And what this does is, when you provided two versions of certain model, or in general, like two SVFs basically in Forge, right? It can look for differences there and highlight them for you, right? So it can highlight newly added objects in the next version in green. It can highlight the removed objects from the original model in red, right? And it can highlight the modified objects in yellow. So this is, I think, the easiest way to get this very nice diffing functionality, if that's what you're looking for. But I think part of that question was also, what if you need to compare only specific types of properties? If you want to track any changes in a specific type of property, then you could do as well if you had like this more customized requirement, because the model derivative service, again, as I mentioned, right, is responsible for extracting all the information from your models, including the metadata, right? So when you process your design files with the model derivative service, it'll also allow you to not only load a file into the viewer or see a thumbnail or see the logical hierarchy in the model browser in the viewer, you can also actually get access to all the different properties of your objects through individual and REST endpoints. Right, so these are the different URLs on the Forge service that you can call, and this last one can be used to retrieve properties, a JSON basically with properties either for your entire model or for a specific object, right? So if you really want to do some custom comparison of just some properties between two versions of a model, you could potentially, maybe you wouldn't even have to use the viewer, right? Your application could simply use this endpoint to get the JSON properties for the first version and to get the JSON properties for the second version of your model. And then you can compare the JSONs, right? Or you can use some third-party tool to detect changes between two JSONs, for example. All right. So I hope that answers the question. If not, feel free to ask again and clarify, and I'll stop the recording for now. And we'll continue in 1 hour and 10 minutes. And we're recording again. Hello, everyone. Welcome back one more time. Before we move on to session number 2, I see one question in the Q&A asking, what is the purpose of translate? How does it work from the API perspective? All right, so for those of you who are new to this, basically the way Forge works, right? Or I mean, viewing designs in Forge, the way it works is that you will always want to translate or convert your designs using the Forge model derivative service, right? So Forge Viewer, the component that we're going to be using now, it cannot really load those 60 different file formats like SolidWorks, Inventor files, or Revit or IFC files, right? It cannot load and read those directly. That would be pretty difficult thing to do. The viewer does provide a couple of file formats that you can load into. File formats such as the SVF, the format generated by the model derivative service, or PDFs, or actually DWGs, right? So standard AutoCAD drawings, for example, you can load directly into the viewer, but that's a really more of an exception, right? So the standard way to work with Forge when you want to view or preview your models is sending your designs to Forge and translating them, or again, converting them with the model derivative service. So what this, just to repeat, what this translation will do, let's look at the model derivative service. The translation, when we submit a translation to the model derivative service, and again, going very low level, that would be done by submitting this job post request. This is where we can ask the model derivative service to start translating or extracting all sorts of metadata from our particular design sitting somewhere in Forge. And again, what will happen at that point is the model derivative service will start inspecting the files, the designs, and it'll start extracting all sorts of information, things like thumbnails, logical hierarchy of your design, right? So for example, in case of an inventor file, that could be the assembly hierarchy. And in case of, let's say, Revit files, this could be your Revit family types and instances and things like that, right? And then it'll start extracting all the different 3D views or 3D geometry that may be available in your designs, all the different 2D drawings, right? And the model derivative service will then capture all this information about what it was able to extract from our files, from our design files, in that thing called the manifest that we were looking at earlier using the Visual Studio Code extension, right? So if I right-click one of my files sitting in Forge, I can check the manifest of the file, and I can see all the different outputs that the model derivative service was able to translate or extract from my design, one of them being the SVF format. And again, that is the streamable viewing format that's being used, that can be loaded into the viewer. That's really the main format that Forge Viewer was built for. Okay, and again, this requesting this kind of manifest, that's the same thing as if you look at the documentation of the model derivative service in Forge, right? That would be this get manifest URL. So you could actually get the same JSON by making a web request to this specific URL, right? To get all this JSON with all these details about the outputs that were created, that were extracted from your design by the model derivative service. That's why the translation is used. Now, if you're building your own Forge application that manages its own data, you'll want to trigger this translation by yourself. But if you're using one of the existing products built on top of Forge, such as Fusion Team, BIM 360, or ACC, they may behave differently. For example, BIM 360 will translate your files immediately as soon as you upload them, right? That's how BIM 360 has been designed. But then, for example, Fusion Team or A360, when you upload a file there, it will not be translated until you actually try and open and view the file in Fusion Team or A360. So be careful about that, right? So when using different products built with Forge, those different products have their own logic of deciding when to trigger the translation. All right. And I see one more question. Sometimes due to very slow network traffic, I get 500 internal server error. How to fix it? For example, increase access token refresh time. Okay, so access token refresh time, I'm not sure if that'll help here. But one typical problem where people run into timeout issues due to problematic network traffic is, for example, when doing things like uploading files, right? Uploading content to Forge can take a while, right? And that's a frequent source of problems where these uploads may time out or may break due to connectivity issues. So for that, I would recommend using a feature of the data management service. So let me switch to the documentation for the Forge data management service. Here, again, you have a standard way of uploading your files through this put buckets, objects, object name endpoint, right? This is the typical simple way of uploading your file to Forge, right? But as you can already see here, the note, if the files you're uploading are larger than 100 megabytes, we recommend that you actually use another endpoint available in this collection, and that is actually for Resumable Upload. This is a feature where you can establish a sort of a session during which you can start uploading your file to Forge in parts, right? So you can, if your file is, I don't know, half a gigabyte, you can start uploading it in chunks of, let's say, 100 or 50 megabytes each. And this has the benefit that, first of all, if your connection breaks halfway through the upload, you can actually resume from there, right? You don't have to re-upload the first half of the file again, right? You can basically just pick up from from the last segment that you uploaded successfully. So you can resume there, right? And again, you have a much better chance of avoiding any kind of timeout problems. So that would be this Resumable Upload. And if you want to learn more about how the Resumable Upload works, I'm sure you'll find some samples in some examples in the different Forge sample applications. I think one that actually talking about the Visual Studio Code extension, here the upload is actually resumable in our Visual Studio Code extension for Forge. And as I was mentioning earlier, you can actually find this one on GitHub. You can find it on my personal GitHub profile, github.com/Petr Broz. And if we look at the VS Code Forge tools, this is the source code of our VS Code extension. And here, let me see if I can find it. That's in the data management, I believe, data management TypeScript file. Here, yes. So I have a command here called upload object that's being used whenever in the extension in VS Code, whenever you want to upload a file, right? So here is where I'm basically using a while loop. This is basically the core of it. I'm using a while loop to upload a file to Forge in chunks, right? So here I'm using some extra cleanup logic to see if maybe some part of the file have already been uploaded, maybe in a previous session of VS Code, right? But here, this is really the core piece where I'm establishing some chunk size, right? Another number of bytes to get from my file that I sent to the Forge data management service. right? So I keep progressing in the while loop. I'm also updating, informing the user of VS Code through this progress bar, informing how many bytes of the total number of bytes have already been uploaded. And again, here, if you decide to cancel the upload, or maybe if your internet connection drops, when you then come back and upload the same file to the same bucket, it'll basically pick up from the last successfully uploaded chunk. So you could potentially use this piece of code for inspiration if you wanted to introduce resumable upload to your own Forge application. Okay, so with that, let's go to session 2. Now we're finally going to start modifying and customizing the client side of our Forge applications. We're going to start by introducing a skeleton of a viewer extension, because typically every viewer extension starts with some class and some registration of this class so that the viewer can later load it. And this will be repeated for every other extension that we will be building today. And I mean, we would recommend following the same structure whenever you are implementing any kind of viewer extension of your own. And then we will start looking at some of the basic viewer APIs, where we can do things like, for example, in this case, capture and handle different viewer events. For example, when the camera changes or when the user selects some element of our design, right? We can react to these events in any way we want. So that's what we're going to do. We're going to see how we can get the list of all the selected objects, how we can retrieve their properties or control their visibility status programmatically using the viewer APIs. All right, demo time. So now let me switch back to the Learn Forge website. So now we're basically, again, if you want to follow on the Learn Forge website here, we're starting with the viewer extension tutorial, specifically with the basic skeleton. All right, so what I'm going to do now is, like I mentioned in session 1, I took a copy of the simple, the first tutorial here, right? I took the Node.js sample code for the first tutorial, unzipped it on my machine, and I should be able to run it now. But what I'm going to do is I'm going to open my Visual Studio Code for this folder. All right, so this is the Node.js application that I'm going to be using today for the server side. But again, you're free to use your own version from Monday or Tuesday, or any of the sample apps cloned from the Github Repo that were part of the Learn Forge tutorial, right? So what I'm going to do is I'm going to start modifying my content in this public folder, because that's where all the client-side assets are. And again, if you're using the .NET version of our samples, you'll probably, if I remember correctly, those asset files are stored in a folder called www.root, right? Again, doesn't make any difference, right? What we're going to be doing is modifying the client-side assets, the JavaScript and index HTML and CSS files. All right, so the process to create your extension typically goes like this. You start by implementing your own class, JavaScript class, that subclasses another class from the Forge Viewer library called Autodesk.viewing.extension. That's what you'll see on the Learn Forge website, right? So we typically start by creating our new class, extending Autodesk.viewing.extension. You know what? Let me copy this content to clipboard again, and we're going to paste it in corresponding file. So let's say this one, our first extension is going to be called My Awesome Extension. So I'm going to place it under the JS folder, right? So this is where I keep all my client-side JavaScript files. So I'm going to create a new file here. Let's say, call it My Awesome Extension.js and paste the content there. You can name the JavaScript file any way you need. You'll just need to use the proper name later on when we actually include this JavaScript file into the HTML page. All right, so now how does the class look like? whenever we're subclassing the Autodesk.viewing.extension, we will want to provide two methods, load and unload. This is something that Forge Viewer will call for us whenever the extension is loaded or unloaded during the initialization, right? And we can optionally also provide a method override for a method called onToolbarCreated. This is a method that the viewer will always call whenever it loads the extension and the toolbar in the user interface is already available, right? So this can be a helpful moment in time for our extension to maybe add some custom button to the toolbar. So this is optional. I believe the load and unload are optional as well, but it's always good to implement these, at least, informing in the console that, okay, this extension is now being loaded or unloaded, which is exactly what we're doing here. So during the loading time, we just simply output a message to the console saying, okay, my awesome extension has been loaded, and we return true, signifying that, yeah, the load was successful. You could also return false if maybe there was any problem if the extension was maybe missing some inputs that are required. And similarly for unload, right, we use this moment in time to actually clean up the UI after ourselves, right? So if we have any kind of group of buttons in the toolbar in the viewer, we make sure that we remove it. And we again just output a log to the console, and we're done with unloading. And in this case, our extension, right, we're already actually customizing the UI, because when the toolbar is created, we're going to take this opportunity to actually insert a custom button into the toolbar, which isn't doing anything just yet, but soon it will, right? So in this case, we're basically starting to use some of the viewer APIs, because every extension will have the instance of the viewer itself available under viewer properties, right? So calling this.viewer basically gives us access to the instance of Forge Viewer that loaded our extension, right? So as you can hopefully see already now, this is a really nice, clean way of wrapping your custom viewer logic in an extension, as opposed to, what you could do is you could start, tweaking your main JavaScript file, and you could start using this global viewer variable to interact with the viewer, right? That would work as well. But then, of course, if you want to introduce another instance of the viewer on the page, suddenly this global code would only affect the first one, right? The first instance of the viewer, and maybe you would want the code to affect the second viewer as well, right? Or if you just sprinkle your custom viewer logic all over the place, it would be really difficult if you later wanted to maybe share this functionality with some other team or reuse it in some other project, right? So wrapping any custom viewer logic in extensions is a really good idea and a good practice, right? So here what we do in the onToolbarCreated method, we basically just check if the viewer.toolbar, which, as the name suggests, is the instance of the actual toolbar that the viewer owns, if the toolbar already contains any control with this name. And if it doesn't, we create one, right? We create, here we're dipping our toes into the Autodesk Viewing UI namespace, where there are a couple of different classes for creating toolbar buttons, panels, combo boxes, and stuff like that. All the UI that the viewer uses itself, right? Most of the UI elements that the viewer uses are also exposed to use through this namespace, Autodesk Viewing UI. A control group is basically a group of one or more buttons that you can append to the toolbar. So if there isn't a control group with this name, we create one. And here you can see we're calling viewer.toolbar.add_control. So as you might have guessed, this is basically inserting this new group of buttons, for now empty, to the toolbar. And by the way, all these properties and methods, you can refer to the documentation of the viewer. So again, if I go to the documentation section in the Forge development portal, I can look at the API reference of the Forge viewer, and this is where you'll find all the classes and all their methods that are available to you. So for example, for the UI, right, the Autodesk.UI namespace, now we're working with a toolbar, right? So we can see that toolbar has a method called add control, index of, remove control, get control by ID. That's exactly the logic we've started using. Here. All right. So now we have our group of buttons ready in a toolbar, right? And now we're creating new instance of an actual button, and we're inserting that button to our group of buttons in the toolbar. And we're giving it some tooltip and some, CSS class for styling purposes. And again, if I look at the button class in the documentation, again, you'll see the different set icon, get state, on click, on mouse over, get ID, set visible, right? All these UI related methods you'll find in the documentation. So basically, we're defining new button, and here we're defining the on click property, right? So this is where we're going to use our custom logic that should be executed when somebody clicks that button. All right, that is for our extension, and now we've already dipped into the viewer APIs and the UI namespace a little bit. And finally, what we want to do is we want to register this extension class under some name so that later the viewer can actually load this extension with this name. When later we can ask the viewer, hey, load an extension with some specific name. This is the name under which we want to register, right? So typically we give the extension the same name as the name of the class that implements the viewer extension. You can name it whatever you want, right? Like you saw earlier, we already provide an extension called Autodesk Div Tool, right? So you can really name it whatever you want. Just make sure that you use the same name later when actually loading the extension in the viewer. So this is all that's needed, right? So you have a class subclassing Autodesk.viewing.extension, and you need to call this the extension manager.register extension. All right, that's for implementing the extension functionality behavior. Now, the next thing, of course, you need to somehow bring this JavaScript code into your page, right? And typically we do that by adding this JavaScript file as another script tag in the HTML. So what I'm going to do here, probably somewhere after the viewer JavaScript, but before our project files, JavaScript files. Yeah, let's do that here. So I'm going to insert a new script tag pointing to, again, to our JS subfolder, to the file called myAwesomeExtension.js. Or if you named your differently, just use, your name of the extension file. So with this, we make sure that the browser will actually, as it's opening our HTML page, we'll make sure that it actually brings in the extension JavaScript code as well, and it'll automatically execute this last line, final line to register this class under a specific name. All right, and I see a question in the Q&A, what the index HTML file actually does. Well, this is the standard HTML markup that defines the content of our web page, right? So in this case, this is a little bit of HTML, again, markup specifying that our page will have some kind of nav bar, right? Some like a header element at the top. In this case, it just includes this A element, which is a link, right? So we say that, okay, there's going to be a link in the nav bar, right? So that when you click on it, it'll take you somewhere. In this case, the link will take you to developer.autodesk.com. You can change it to whatever you want. And then we say that, under the nav bar, there's going to be a container with two columns, right? One that takes this call SM4 is basically a class from Bootstrap framework that we use here, which says that the first column is going to take 4/12 of the complete of the entire area. And then there's going to be another div element that will take 8/12, or, 2/3 of the entire area available to us. So in the first column, we're going to show, in this case, in this particular case, we're showing the list of buckets and objects. And then of course, in the bigger, larger div element, this is where we're going to be showing the viewer. So that's what the HTML page does. It's a piece of markup that defines the layout and structure of our web page, of the index page. Okay, and now make sure while loading the extension below Forge Viewer. Oh, interesting. Okay, let me see. Is there a tip on the Learn Forge website? I can see here, but yeah. So basically, I mean, you will need to pay a little bit of attention to the order of loading files, right? Because, for example, if I put my awesome extension file, JavaScript file to the very top, the browser would try and load it first, but there would be a problem because then it will try and define this class, which is supposed to extend some other class, Autodesk Viewing extension, which does not exist yet, right? So I think that placing this extension file like to the very top would be problematic. So it should be placed somewhere after the viewer JavaScript file itself is loaded, because this is the JavaScript file that will define all the namespaces and classes, including Autodesk Viewing extension. And then calling it before Forge Viewer or Forge Tree is correct, I believe, and fine, because all the code in the viewer here will execute asynchronously anyway, right? Because the Forge Viewer code will really only trigger when we select something in the tree. So I think it's fine to keep the extension where we place it, or we could place it at the bottom here as well. I believe that should be fine. Okay, so now we've made sure that the JavaScript code for our extension is included with the rest of the client-side JavaScript code in our HTML. So that's the second of the 3 steps, right? First is implementing your class and registering. Second is making sure that the JavaScript code is actually brought in the HTML. And third is including the extension name when initializing the viewer. That's the third step, important step. And the way you do it is by passing an additional parameter to the viewer 3D constructor. So when we take a look at the documentation, we'll take a look at the GUI viewer or viewer 3D. It's pretty much the same thing. GUI viewer is a subclass of viewer 3D providing the UI elements. If we look at the constructor, we'll see that it accepts the HTML element, which should be the container for our viewer, right? That's what we're passing in here. But then it also takes a config object. But here it's not super helpful. It just says, refer to the base class, which is viewer 3D. So here we see more information, right? So there is a couple of different options we can pass to the config object. And well, funnily, the one I'm looking for is not mentioned here, because one of the properties you can add to the config object is a property called extensions. So I'm going to create this config object and pass it as a second parameter to the constructor. Format this so that it looks better. And one of the properties that are available there is called extensions, which is an array of strings. And this is where you can specify the names of extensions that you want to load into your viewer, right? So my extension, I named it my awesome extension. So I'm going to take this string, and you can take whatever name you chose for your extension and use it here. With this, I'm basically making sure that's the final step, final of the 3 steps when building a viewer extension, right? Making sure that the viewer loads this extension when it's ready. And then again, you may find some third-party extensions like the Autodesk Div Tool, right? So we could potentially try adding like Autodesk Div Tool, or maybe there are others. I remember we had like there was a document browser extension that would, for example, add a new button to the toolbar, allowing you to see all the other outputs from your translated file and switch between them. Right. So this is what you could try. We can maybe experiment with this later when we have time. All right, this is it. Now our extension is implemented. It's included in the HTML, and it's loaded by the viewer. Right. So we can give it a try. Let's see, when we run our app, I'm going to run it in the command line for now. All right, it's listening on port 3000. So now what I'm going to do is, before accessing the page, I'm going to open the DevTools and switch to the console, because if our extension works correctly, it should output some console log messages. Right now, of course, it's not loaded yet because we haven't launched the viewer. And as soon as I select some design from the bucket, okay, I actually had a breakpoint here. You can see in the console that we actually got a message from our extension, right? This is where the viewer called our load method, and we just informed in the console that, okay, our extension is successfully loaded. And you can now see that it's actually available in the toolbar, right? It doesn't have any icon yet because we haven't really provided any, but it's already there and it's working, right? But now when we click it, it's not really doing anything because we haven't specified any functionality in the on-click method. Okay, now I see another question. Is it doable to directly customize BIM 360 viewer in the near future? Okay, I see. This is a request we get every once in a while as well. Customers are wondering if it's possible to somehow customize the viewer used by BIM 360 itself, right? So BIM 360 is a product built on top of Forge, and of course it uses its own instance of Forge Viewer as well, but it doesn't really officially allow any way to customize the experience of the viewer. The only customization that I'm aware of is, I think there is a way to insert like your custom card to the BIM 360 dashboard that could potentially show some custom data of yours, but the viewer itself officially cannot really be modified or customized in any clean way. But one thing here just to note here is, we're dealing with web technology here, right? And this is just JavaScript running in your browser, and modern browsers like Chrome or Firefox give you a lot of ways to interact with any JavaScript logic, whether it's our custom app or BIM 360 or any other web application. So in this case, that's actually a good segue. I mean, just to experiment with what you can do with the viewer APIs without really doing this, update my code, reload page, update my code, reload page cycle, right? You can actually interact with the viewer APIs directly during runtime, because the viewer, right? If you remember, we defined in our code the viewer as a global variable, which means that it will be accessible in the global scope from within the console, right? So here, if I type viewer, that is actually the instance of our viewer. And I can do things like viewer dot, I don't know, let's see, dot get selection. That will give me the IDs of all objects that are selected, right? So, and what I could do here, I could also say viewer dot load extension, which is another method you will find in the viewer documentation that is used to load another extension during runtime, right? So if there is one, I don't know, let me see, Autodesk document browser. I'm not sure if I'm remembering the name correctly. Okay, that worked. So what just happened was that I took the instance of the viewer that's currently on my page, and I asked it to load one more extension into it. And look what happened. We got a document browser icon appearing in the toolbar now, and we could potentially use this to if this DWFX file generated multiple outputs, we would see them here, and we could use this panel to switch between them. So this is basically one way for you to kind of sort of hack your viewer in BIM 360 if you want to, right? Because you could use this, you could basically open the console and interact with the viewer instance used in BIM 360 if you want to load some custom functionality to it. But in terms of official ways of customizing the viewer in BIM 360, no, as far as I know, we do not provide any options for that. All right. So that is it for questions. I think we can move on to the next part, which will be, so now we're done with our basic extension skeleton. Oh, and by the way, we can specify some additional CSS because if you remember, when we create the button in our new extension, right, we gave it some CSS class called myAwesomeExtensionIcon. So we could use this to basically provide some CSS styling for the new button as well. Let me see. We can copy this piece of CSS and add it to our main.css, or again, you can create a separate CSS file if you want to as well. That would work. But again, then remember to import that CSS file into the HTML page. But here I'm just going to reuse the CSS file we already have. So here's where I can specify some, things like background image, position of the background image, size of it, right? Here, but I don't have any icon PNG file at the moment, so I can probably just comment this out. Right, so if you have your PNG sitting somewhere in the public subfolder or www root subfolder, you could, use your custom PNG as an icon for the button. But for now, I'm going to leave this empty. All right. Okay, and I see one more question. If I load multiple models in the viewer, the document browser extension will only show one model. That is correct, because there is a difference between loading multiple models that are really unrelated to each other. And then it's different from loading a single model that may have a couple of, I would call them siblings, right? So when you load, let's say, a specific 3D view from a Revit model, that Revit model may actually have generated some additional 3D views and some additional 2D sheets. So in that case, the document browser extension will show you all the siblings, all the other outputs that came from the same input file, right? That's what the document browser extension is doing. But loading multiple unrelated documents or models, really, right? That does not work with the document browser extension. In that case, if you want to see all of those different models, you'll probably just need to use the model browser panel in the viewer. Okay. So now we're done with adding our extension to the viewer, right? And we can move on to the second part of this session, and that is finally starting tweaking the extension to do something for us, to start interacting with the viewer, right? With the handle events and check the state of the viewer or control the state of the viewer. Okay, so what I'm going to do now is we could probably just start modifying the My Awesome extension. But instead, what I'm going to do is I'm going to copy this one, My Awesome extension. I'm going to make a copy of it. And I'm going to use the My Awesome extension as the skeleton for any other extensions we'll be creating today. Right, and this one, the new one, is going to be called Handle Selection Extension, just to be consistent. Selection extension. So just to be again consistent with the LearnForge website, I'm going to use the same names. So here I'm going to replace all the My Awesome extension with Handle Selection Extension. Selection extension. And I have my new extension, right? That again isn't doing anything, but we're going to fix that. We're going to fix that soon. All right, handle selection extension. Let's going to look very similar, right? So we're going to be creating, again, just informing in the console when we're loaded or unloaded. Same thing. We're going to try and create some control group in the toolbar, right? Same stuff as before. And creating a new button that does something. Here, maybe I'll just change the tooltip to selection, right? Up to you. I mean, this may not be the exact same thing as in the code snippet and LearnForge, but you get the idea. Again, we're basically just adding a button to the toolbar that's going to do something. We're going to specify the behavior here on line 36. And we're again registering the class under some custom name ID. In this case, that's going to be handle selection extension. So again, that's the first of the 3 steps that we need to take when building your extensions, right? Defining the extension itself, registering it. Second thing is making sure that we actually bring it into the HTML. So I'm just going to copy it here and say script src, right, to load in the JavaScript file and handle selection extension file. And the third one is the third of the 3 steps is making sure that our extension is loaded by the viewer, right? So it was called handle selection extension in my case. Again, if you use different name for your extension, just make sure to use the same name here to be consistent. All right, that is it. And now we can start. And again, I'm going to ignore the CSS for now, right? Because actually, look, this one looks better because this CSS style actually brings a PNG from GitHub, which is easier for me. So I don't need to go looking for some PNG files to download to my source code here. All right, so what I'm going to do is I noticed that the class we were using in the CSS was actually handle selection extension icon with lowercase h. So I'm going to go back to my CSS file and paste that CSS style handle selection extension icon in here. So this will basically make sure that my new button that I'm adding to the toolbar will again use 24 pixel size of the background image. It'll grab an image from GitHub and center it, right? Okay. Now my app is still running on port 3000. So if I go back to the app and reload it, let me just open the Dev Tools just in case to see if anything goes wrong. And I load my sports car model. Okay, you can see that both extensions, the My Awesome extension as well as the handle selection extension have been loaded. And now I see another button in my toolbar, and this time even with a PNG image, right? So this is where we're going to start implementing our custom handle selection logic. All right. Again, now it's not doing anything yet. Okay, now this is where we finally start playing with the viewer APIs. So let me copy this code inside the on-click handler in our extension, right, for our button. So now it's not doing anything yet. So I'm going to paste this code inside it, and I'm going to explain what it's doing. All right. So when somebody clicks that button in our toolbar, what we do is we're going to ask the viewer APIs to get us a list of IDs of all the objects that have been selected by the user. And we're going to store that in a list called selection. Then we're going to ask the viewer to clear the selection, right? Maybe in this case, you don't have to, but in this case, we've decided to build this logic, this behavior, so that when the button is clicked, whatever is selected, we store the list of the IDs of those selected objects, and we clear the selection. And then if the selection is not, if the number of things that were selected wasn't empty, we will basically iterate through them using this selection.forEach, right? So again, the selection is a list of numbers where each number represents the ID of an object that was selected. We will iterate through them. And then for each of these IDs, we will use another method on the viewer class called getProperties. And again, if you don't know what parameters should go to this method, you can always go back to the documentation. And if I look at the viewer 3D, I can search for, let's say, get properties, right? That's the method we're calling right now. And as you can see, what it does is it retrieves the properties of the metadata for a specific object ID. And it does that through 3 parameters. First is the number, that's the ID of the object. Second is a function that should be called with the results if the retrieval was successful. And third parameter is the function that should be called when there was some problem. And that's what we do here, right? So we pass in the number. That's the first parameter. And then the second, we provide a function that should be called. And then the third, the error function, we ignore it here for now, right? Just for the sample purposes. So what we do is, in this callback function, once the properties, the results are retrieved for that specific object ID, we log them to the console, all the properties. And then we use this built-in confirm function, which is basically available in every browser JavaScript engine. And it basically pops up some message asking the user, the visitor of the web page, some question with yes or no answers. So we ask the viewer, the user of our website, do you want to isolate this specific object? And for that, we actually display the name of the object that we've retrieved from the properties. And also show its external ID. That's another property that is available on every object that we load into the viewer, right? And if the user confirms, if we hit the yes or okay button, right, this function will return true. So in that case, what we're going to do is we're going to add the ID of this object to our list of numbers called here isolated. And what we do is we call another method on the viewer object, the viewer API is called isolate. This is what you can do to programmatically isolate a certain subset of objects. Isolating meaning you leave them visible and then you make everything else invisible or semi-transparent, just to bring this subset of objects to the user's attention. And that's it, right? And if the list of objects that were selected was actually empty, all we do is we call the viewer isolate method with a parameter 0, meaning basically unisolate everything, right? So make everything visible. So this is basically a way to reset the isolation, the visibility status for all the objects in our model. And that's it. Well, let me switch back to our live demo and reload the page. Okay. Below our model, let me double check the Dev Tool to see if there are any errors. No errors here, so we should be fine. So what I'm going to try is I'm going to select this windshield and maybe the caps lock enabled here. All right, so I've selected the windshield and let's say this rim, right? 2 elements. Now, if I hit the handle selection toolbar button, okay, it's now asking me, do you want to isolate the rim object? Maybe I'll say, no, I don't want to include this one in the isolates list, right? And then it'll ask me, do you want to isolate the windshield? And I'm going to say yes. All right, and as you can see, what happened is we call the viewer.isolate function just on the ID of the windshield, right? So the windshield remained visible and everything else was made semi-transparent or invisible. You can change the behavior of the other things when isolating an object in the properties. We're using this ghost hidden objects, right? So if it's enabled, all the objects that are hidden will still remain visible, at least this way, right? But if we disable this option, they will be just gone completely. All right. And that, I believe, is it for session 2. So now it's your turn. Try and see if you can follow along. Try these steps as well. So again, build your first viewer extension. And again, remember, it's 3 steps, right? Defining the JavaScript class and registering it. Second, loading the JavaScript into your HTML. And third step is including the name of your extension in the viewer constructor to make sure that the viewer actually loads it, right? And then try and see if you can maybe duplicate this skeleton extension and build another extension that again adds a toolbar button, right? And when somebody clicks on that button, it will use the viewer.getSelection method to get a list of selected objects. It'll iterate through them. It can use the viewer.getProperties method to retrieve some of the metadata extracted for this element by the model derivative service, and maybe try and use the viewer.isolate method to isolate objects and hide all the other objects. Okay, and let's see if there are any questions. I see one. All right, that's a good question. What is the difference between DB ID external ID? All right, very good question. So the SVF file format that I was talking about, right? That's the proprietary file format used by Forge that can be loaded into the viewer. This SVF format uses its own mechanism for ID, generating IDs. It's basically just numbers, sequential integer numbers starting from 1, right? So any object you select in your 3D model or 2D drawing in Forge Viewer will have its own DBID, right? And again, it's always just a number. So you know, it's like if I select this trunk lid and I say viewer.getSelection, right? It's going to have some ID. If I select the door, it's going to have some ID. Now, these IDs are not persistent. And what that means is that if I were to take this DWFX file, open it, let's say in AutoCAD, modify it and upload it to Forge again, these numbers maybe wouldn't be the same, right? Because they are simply assigned to every object as it's being converted by Forge. But maybe if I update this sports car model, if I don't know, remove the door, add some other door, when I translate it with Forge again, the door most likely wouldn't have the same number, 71, in the next version of the DWFX file. And that's why it's really important to keep that in mind, that these IDs are not stable or not persistent, as we call them. But it's precisely for this reason that we provide some additional form of IDs, and we call them external IDs. So now let me show you something. Let's say I want to retrieve all the properties for this door, right? What I can do is, just like we're doing in our extension, I'm just going to call viewer.getProperties. I'm going to pass in this number of our object, right? That's 71. And I'm going to say console.log and console.error. So I'm basically saying, hey, viewer, try and see if you can get any properties that were extracted by Forge for the door of this car. And if you can, log it to the console. And if you cannot, just output it as an error to the console. And here you can see this is the result returned by the getProperties method call, right? In extent, so we can see Forge was actually able to extract 12 pieces of properties for our door. So the author, material, density, part number, designer, whatever have you, right? Of course, these properties will be different depending on the file formats that you're sending to Forge, right? If you upload an IFC file or Navisworks or Revit or DWG drawing, right, you'll see different amounts of different types of properties, of course. But what's important here is you'll notice that every object, no matter whether it's coming from an IFC, Revit file, drawing, DWG, DWFX, SolidWorks, Bentley DGN, doesn't really matter. Every object will have some kind of a string as its what we call external ID. And this is actually an ID that will look differently depending on the input format. So for example, if we're going to be working with Revit, every object in your design will have the external ID set to the Revit GUID of that object, right? If you're working with IFC files, every object in your design in the viewer will have the external ID property set to some kind of IFC GUID. If you're working with, I don't know, like in this case, we're working with WFX file, right? This is some kind of a unique string ID that represents this door in the original DWFX file. And with that, this is actually what this is how you can get the stability of the IDs across versions of your models, right? So if for any reason, let's say you want to start storing some additional information in your SQL database for individual elements of the design, it would be a good practice, recommended practice, to link your custom data in your SQL database to the individual elements by their external ID, right? Because that way, if somebody updates the model and uploads a new version of this car to Forge, right, the door may no longer have the internal ID 71, but it will still have the same external ID DOLORQN, da, 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 da. Okay. All right. And I see one more question. Is there any bootcamp coming about data visualization? That's a good question. Not as far as I know. We do plan to run another accelerator though. So if you go back to the Forge developer portal and look at the community, you'll see different types of events that we run, like this online bootcamp. Another type of event is an accelerator, where it's another free event that you can join and basically join us with some idea about a prototype that you would like to build, implement using Forge. And we basically, you know, sit with you, at least virtually for now still, and help you build that prototype. And we always try and use the data visualization APIs there as well. So that would be one way for you to learn about the database API. So you could join one of these upcoming accelerators, where again, we spend a week with you and help you build whatever idea you have in mind during that time. And that could be something with the data visualization APIs, for example. All right. So with that, it's your turn now. I'll pause the recording, pause the screen sharing, and we will see you back here in roughly 1 hour when we move on to session 3. All right, good luck. Okay, hi everyone, we're back. Welcome back to the session 3 time. Now, before we move on there to the third step, one more minute to anyone who might have any questions. There have been a couple, and one was kind of interesting. If you start noticing some weird issues where you make modifications to your client-side JavaScript or CSS or HTML files and you don't see the changes in the browser, try hard reloading your page, because in some cases the browser might be a little bit too proactive, trying to be efficient and caching the assets in JavaScript files, CSS files. So when you make some changes to your client-side code, these changes may not immediately appear in the browser when you reload the page. So if that happens, just try hard reloading the page. So not sure what key combination that is on Windows, but I think on Mac it's Shift-Command-R, the hard reload. Or you can try right-clicking the reload icon in a browser, and that should give you some sort of a hard reload option there. Actually, let me try that on my end here. If I right-click the reload page, I don't see that there. Okay, never mind. I thought that was available. But yeah, I think Shift-Command-R, yes, in this case, it's a hard reload. Okay, and if there are no other questions, we're moving to session 3, step 3, where we're going to start adding some custom user interface to the viewer through our new extension, right? So for now, we've only added really a toolbar button. Now we're going to add more. What we're going to do is we're going to create yet another viewer extension that will create a completely custom panel inside the viewer for us. And we'll basically, what we're going to do is we're going to try and compute some sort of summary from the properties of our elements, of our design's elements, and we're going to try and show the summary results inside that panel. That's going to be the first half of this session, and then in the remaining time, we're going to start preparing data for the final session today, when we're going to start adding dashboards and charts to our Forge app, right? So in this session, we're going to do some data prep to make sure that we have all the data ready for the final session to actually show this data in the dashboards. Okay, so let's switch back to Learn Forge website. And now we're moving to the docking panel segment, docking panel tutorial. So once again, we're going to be creating a new extension. We could probably just copy the original skeleton, or we can maybe just grab a copy of this code snippet from the Learn Forge website and use that as our new extension JavaScript file. In this case, we're going to call it model summary extension.js. Right here, I'm going to create a new file here under my JS folder called model summary extension.js. And I'm going to paste the extension code snippet there. And again, just briefly, let's see what this is doing. Again, it's the same kind of extension skeleton, right? So we just subclass the Autodesk.viewing.extension class, register it with the Forge Viewer extension manager through this one line of code, Autodesk Viewing.the extension manager.register extension, so that this name can later be used in the viewer constructor as we're instantiating Forge Viewer and want to make sure that the extension is loaded there. All right. And the same thing for the toolbar, right? Create on toolbar created method. When the toolbar is available to our extension, we're going to make sure that we insert our button there. Again, I'm not going to worry too much about adding any image to it for now. We're just gonna, we will worry about the actual functionality provided by the extension. Okay. Or maybe we can, let me just copy and paste the CSS for completeness as well. So again, what we're doing here is we're providing some additional CSS styling to this new button that we've created, because we gave the button a CSS class called model summary extension icon. So what we can do is add a piece of CSS, in this case, into our main.css file. That's the easiest place, right? Because that one is already being loaded by our web page. And we're again setting some PNG from GitHub as the background image with a specific size and placing it at the center of the button element. All right. And again, we must not forget to include the extension JavaScript file into our HTML page to make sure that it actually gets loaded. All right, so I'm going to create another script tag here, and I'm going to have the JS model summary extension JS file loaded here. This is again just to make sure that the JavaScript class will actually be available to our web page here. That's the second of the 3 steps, and the final step, as usual, is making sure that we actually load the extension into our viewer. So what I'm going to do, I'm going to maybe remove these for now so that they don't confuse us. And I mean, we worked on those in the previous session. For now, we're just going to worry about this new extension adding our custom panel user interface. And the extension was called model summary extension. All right, so this is the name I'm going to use here in our config object. Okay. And now we're again getting, our extension is ready, right? It's not doing anything yet, but it's now ready. It's going to load with the viewer. And it's going to appear in the toolbar, but clicking on that toolbar button isn't going to do anything just yet. Okay. And I think this is a good time to go back to the question that was posted earlier by Dbid. The question was, or the request was to provide a site example explaining computing data like short an array of objects. I think I'll try and cover that in this segment now, because again, what we're now doing is we're using the viewer APIs to retrieve all sorts of data that was extracted for our design file by the Forge Model Derivative service, right? We already did a little bit of that in the previous session when we were using the viewer.getProperties method. But the viewer actually provides a couple more options, more ways of accessing the logical hierarchy and the properties and everything, all this information from your models. So first thing we'll need to do is, for this extension, we want to show some custom panel user interface with some summary data that we will compute for all the different nodes in our model, right? But before we do that, we actually need to be able to find out which are all the leaf nodes in the logical hierarchy, right? So that means nodes that have no more children, because let's say in this case, we only want to compute some summary just for the metadata on the leaf objects that don't have any other children, right? We don't want to include any data from groups of objects. We just want to get the leaf nodes, as we call them. So we're going to have to somehow find out what those leaf nodes are, which objects in the tree are the leaf nodes, right? So that's going to be a list of numbers. That's going to be a list of object IDs, but we need to find those first. And the way we're going to do that is in our new extension, in the model summary extension, we're going to prepare this helper method called getAllLeafComponents. And let's take a quick look at what it does. We can add that method at the end of our model summary extension. Now, what it's doing is it's basically using another method on the viewer object called getObjectTree. And this will basically return an object which is of the type instance tree. And this object allows us to query all the different relationships in the logical hierarchy. So it allows us to find out who are the children of a specific node, who is the parent of a specific node, what, I don't know, who are all the geometries attached to a specific node or ID. All that information that is kept by the logical hierarchy structure, this tree object will help us query that information. So what we do is first we start by calling viewer.getObjectTree. There's a couple of ways of retrieving the tree. This is the typical one, right? So calling viewer.getObjectTree, but be careful here. This is not a synchronous method. So you cannot just say tree equals viewer.getObjectTree. This will actually this method may need to go to compute some data, parse some information from the SVA file first before sending that tree object to you. So this is an asynchronous method. And what that means is that we will need to provide some sort of a callback mechanism that will be called, some callback function that will be called as soon as the tree object is ready. So that's what we're doing here. We're passing in a function that will be called as soon as the instance tree is available, right? And when it is available, what we do is we call one of the methods on this instance tree object called enumNodeChildren, and we're also calling this tree.getRootID. So getRootID is basically a way for us to quickly find out what is the numerical ID of the root object of all the objects in our design. And by calling the enumNodeChildren, we're basically asking this logical hierarchy structure to tell us what are all the different IDs of all the children of this root, right? And again, this is an async, sorry, not an async method, but in this case, This will basically call our callback function for every ID found under that root. And what we do inside is for every one of those IDs, we ask this tree structure again, whether that specific object ID has any children or not. And if it does not have any children, in other words, if the response from the get child count is 0, we push this ID into our list that we're building, right? So again, what we're doing here, we're basically taking the ID of the root object of the logical hierarchy. We are iterating through all its children, all the other nodes under this root, and we are asking each node if it has any children. And if it doesn't, we consider it a leaf node and we add it to the list of leaves. And again, since this whole thing is asynchronous, that basically makes our get all leaf components method also asynchronous. So whoever calls our method to find out the IDs of all the leaf objects will also need to provide some function that we will call later when the results are actually ready and available. Okay, so again, this is just our helper method that will collect the IDs of all the leaf objects in our tree that don't have any other children. And yes, there's a good question in the Q&A. By using this true flag to the enum node children method, we're basically recursively traversing all the children of the roots and all their children and all their children and all their children. So those are all the objects that you see in the viewer, all the individual selectable elements, right? So that's, let me see. If I start my sample app locally and I go to localhost, what I mean by the children, it's basically all the objects you'll see in the model browser. All these groups, all these elements, all these individually selectable elements are basically nodes that have had their IDs, right? So this is the logical hierarchy that we are now traversing using the instance tree object. We're asking, so we ask for the root that's on, let's say, the model itself, and then we're asking for all the objects underneath it. So that's going to be all these groups and individual objects. And for each object, we ask the tree structure if that object has any children or not, right? So if we ask about this wheel 2, 3, we will find out that that actually has 3 children. So we're not going to be storing that in our array, right? But when we ask about this disk 1, column 1, that one has no other children. So the ID of this disk we will actually put into our list. All right, now there's a question. Can we download each object individually? I'm not sure what you mean by downloading, but there is a way to actually, when you're loading a model into the viewer, there is a way for you to specify just some subset or an individual object from that model that you want to load, if that's what you're asking about. That's a bit more advanced topic, but yes, it is possible by specifying the ID of the object when loading your model into the viewer. Okay, now are children including nested Revit families with their sub-elements? I'm not sure if I understand. Are children including nested Revit families with their sub-elements? I'm not sure, to be honest. But I don't think that, SVF format itself has any concept of families and family instances. So I think if you have a Revit file and you run it through Forge, if you have like multiple instances of a family, what you will see in the model browser are really just the instances, right? And then the family will be just a group, a node representing that group. But I'm not sure if that answers your question. Okay, so a Revit family can have nested Revit families. Can I select those? I don't think so. So I have to apologize. This is getting deeper into Revit that I'm not really that experienced with the Revit internals. I'm not sure, but I don't think that if there's any way to like nest Revit families within Revit families, that I'm not sure if those will be available to you in any way inside here. So here, if you'll see an instance of a family, I think that's going to be a leaf node. I don't think that that's going to be, expandable, that you'll be able to select any of the nested families. I don't think that's the case. So if that's something you're interested in, I would recommend that you use the forge.help@autodesk.com email to ask, or ask on Stack Overflow, and we will try and get someone who's more familiar with the Revit specifics to help you there. All right. So let's go back to our the LearnForge website. So now we've got our helper function, helper method that will collect all the IDs of all the leaf nodes in our tree. And we can move over to actually start defining our custom panel. To do that, again, if I were to go back to the documentation for the Forge viewer, you'll see under the Autodesk Viewing UI namespace that you also have, apart from the button and toolbar, you have some additional classes like docking panel. That's the UI that we're going to be using in our case in this extension. So a docking panel is basically a base class for all the different panels you see in the viewer, like the model browser or the properties dialog. All of these are subclasses of the docking panel. And you can create your own subclass of docking panel as well. That's exactly what we're going to do, here. Let me again just quickly copy this code snippet and add it at the end of our extension file. So we're back to the model summary extension.js file. And here, after our extension class, we're going to add this new class, right? Where again, we are extending. Well, actually, sorry, my apologies. Not the docking panel, but a property panel. So it really depends on the structure in which you want to visualize your data in the panel, right? If you have something completely custom where you would like to show some completely custom content inside the panel, you would use a docking panel. But in this case, we actually want to have maybe show like a key value pairs of data, and that is already something that's available to you. That's basically the properties, right? So this panel is actually derived from a more specialized class called property panel, which is used for any kind of panel that shows these two columns, key value pairs, and potentially some collapsible groups of categories of these key values. So to make our life a little bit easier and to leverage more of the Forge viewer functionality, we're actually going to create our panel as a subclass of property panel. So then we don't have to worry about defining some HTML layout for the first column and for the second column and for the collapsible property categories, because this property panel will provide that for us. Okay, so we define our model summary panel. For now, it's not being used anywhere just yet, but we're going to use it soon. That's basically now getting to the implementation of the click handler for our new toolbar button, right? And what we're going to do is when somebody clicks on this toolbar button that our new extension includes in the toolbar, we will check if our new UI panel is initialized, and if it isn't, we're going to just get a new instance, right? So we're going to call this constructor for our custom property panel, passing in the viewer, and viewer.container is really the DOM element in which the viewer itself is hosted. And the property panel, the class from which we derive, uses this information to know where in the HTML, where in the DOM tree exactly the panel should be attached. Everyone can give it some ID and title. Okay, and with this line, we basically toggle the visibility of the panel. So if it was visible and we click the toolbar button, it'll disappear. If it was hidden and we click the toolbar button, it'll show. Okay, And then, yeah, if it's hidden, we're going to skip the rest of the logic here. But now, if the panel is visible, here is where we're going to use our helper method. See, that's the method we implemented a moment ago that will collect all the IDs of all the leaf objects in our model. And when the results are ready, we pass in a callback function that will be called when the IDs are available. We will do something here. So let's take a look. Let's analyze this callback function and see what it does. We call this viewer.model.getBulk properties. So remember, a moment ago, I was mentioning that there are a couple of different ways of retrieving data from your Forge models using the viewer APIs. One way was the viewer.getProperties method, right? This is another option where calling viewer.model will actually give you access to the instance of the actual model that you loaded into the viewer, right? And that model itself, if we look at the documentation, that's the model class. And that class itself also has some additional properties you can call, like the one that we're trying to call right now, called getBulk properties. This is pretty helpful because, you know, before what we were doing is we were calling the get properties individually for every single object, right? In the previous session. That may not be the most efficient thing to do because every request for these properties is actually involves quite a lot of work because the viewer needs to send a message to a web worker, which is sort of like a separate thread running inside your browser. That web worker needs to go through some specially compressed database to extract all the properties for that one specific object ID and send the results back from the web worker to your main JavaScript context, right? And even sending this amount of data involves some overhead. So you don't want to be calling get properties for individual objects all the time because that's just going to slow down the whole application. So in those cases, if you happen to have a list of IDs of objects that you want to get the properties for altogether, you can actually use this other alternative method called bulk properties. So in this case, instead of specifying a single object ID, you can actually pass in an array of IDs, and this getBulk properties method will retrieve the properties for all of these together, right? So all the computation for all the objects will happen in the web worker at once instead of you jumping back and forth for every single object ID, right? And what's even better is you can even, in the second parameter, in the options, you can specify just the names of the properties that you want to retrieve, right? So maybe you're not interested in all the properties for all these objects. Maybe you're only interested in some specific property name for all these objects, right? So you can even provide this filter to only say, I'm only interested in this property name and this property name for all these object IDs. All right. So that's exactly, where am I? Here. That's exactly what we're doing here, right? So we're basically asking this specific Forge model loaded in our viewer to give us all these properties called property name A, property name B, for these object IDs. So of course, it's not very likely that our models would have properties called property name A, property name B. So this is here as a placeholder. We will want to change these two strings based on the models we're working with, right? So in my case, I have a DWFX file, so maybe I'll look for some property name that could be available for that specific file type. If you're working with Revit, you may want to use different property names. If you're working with Inventor files, you may need to use different property names here as well. All right, and when the results come back from the getBulk properties, which is once again an asynchronous method, right? So we need to provide a callback function that will be called when the results are ready. We simply iterate through every single item. So the response from the getBulk properties method will be a list of objects representing the individual object IDs that we requested, and each object will include the properties for that specific element ID. And here, this looks maybe a little bit confusing, but these couple lines of code are basically building a histogram, and let me try and explain. A histogram of which values appear frequently for a specific property name. So let's say I add a color as my filtered property. So maybe I will only be looking for properties called color. And with these couple lines of code, I'm basically going to build a histogram showing me how many objects in my design have the color set to red, or how many objects in my design have the color property set to blue, or how many designs have the color property set to green. So that's sort of like, that's what we're building here, right? Filtered props. Oh, this is actually probably a typo here. We will probably want to store this in a separate, we're treating this filtered props object as a JavaScript object, when in fact it's an array and a const. So this is probably a typo. So you know what, let's copy this code, add it to our extension, and clean it up a little bit. So basically, this is all the logic we want to run when somebody clicks on the toolbar button, right? So that's here in our button.onClick property. Okay. So what I'm going to do is I'm going to leave the filtered props, and maybe, well, let me check. If I go to my application, and in my case, again, this may be different for you because you may be experimenting with a Revit file or with Inventor or with a drawing file. But here, since I have this DWFX file, I don't remember what types of properties are available. So let's see. So I can see things like material, which is generic for everything. So that may not be the best one to use. Density, label. Number. Okay, so maybe what I'm going to do is, in my case, it looks like this part number might be a good candidate for my summary computation, right? Because the part number is available on every object, and it has like a couple of different values depending on what I select, right? So if I select the rim, part number says rim 2, chassis, left door, front windshield, or maybe actually headrests, interior, tire one. Well, we'll see. We'll give it a try. We can then maybe experiment with some other properties, but for now, I'm going to try and use the part number. If I go back to my code, I'm going to say that the only property I want to retrieve from all my leaf nodes is the part number. And again, you feel free to use any property that you see in your own models. Okay, and I'm going to ask for the values of this property for all these leaf nodes, all these object IDs. And then I iterate through them. And let me fix this. I'm going to say I have a histogram. And here, instead of modifying the filtered props, I'm actually going to work with this histogram object. Right, so here I'm basically, what I'm doing is I'm checking if that histogram object already contains a property called some property name, right? So this could be chassis in my case. And if the histogram has no property chassis, I'm gonna define that property on the histogram object and set it to an empty JavaScript object. Right, so here is basically, I'm just making sure that my histogram object at the top level has properties that correspond to the different values that can appear as part number in my case. And then in this case, I start counting the number of occurrences of that specific property value, right? So so for the property name, yes, if there is no property value like a part number chassis defined, I'm going to set it to 1. And if there is, I'm going to increment it by 1. So ultimately, the histogram object, in my case, because I chose the filter property props to be just part number, ultimately, the histogram will look like this. At the top level, it will have part number, right? That's the prop display name. And if I included more, maybe, I don't know, material, it would appear here at the top level as well. And then for every of these two properties, I would keep track of which values appeared how many times, right? So I could maybe by updating this histogram, I will see that part number chassis appeared twice. And that material, I don't know, glass appeared once, and then material steel appeared 5 times, right? So this is the type of object that this code will generate for us. Again, sort of a histogram showing for which properties, which values appear how many times. So you feel free to experiment with these, choose any property names that appear in your own models, and something we can play with that and tweak that later. All right, and that is it for constructing the histogram. And finally, what we're going to do is, see here, we're calling this._panel.add property. This is actually our property panel, but we're going to start adding key values to it. So here, what we do is we iterate through all the different filter properties we've specified here at the beginning, and we check the status in the histogram. I think for now, what we'll want to do is this should change. This should be histogram. Right, so we're asking if for this particular property, like part number, if there are any results at all. And if there aren't, we skip this step. Otherwise, this object.keys is basically a built-in way of in JavaScript in the browser to find all the different keys of an object. So let's say for part number, that's this JavaScript object. And when we call object.keys, that will basically return chassis. And then if we call object.keys on this object, that will return 2 strings, glass and steel in my case, right? So we're basically, this construct is iterating through all the nested properties of part number or material in my case. And we're basically adding new key value to the property panel, right? Saying, okay, so part number chassis appeared 2 times, material glass appeared once, because the add property, if we look at the definition of that method in property panel. Oops, okay, maybe not. Why don't we see it here? Okay, so for some reason that property panel, and I think that actually happened last time as well, I forgot. For some reason it's not included in the documentation. But anyways, for now, okay, so just keep, just remember that the add property panel, basically, the way it works is that it accepts 3 parameters: the property name, property value, and property category, right? That's those expandable, collapsible groups of property and property value pairs. So we're basically going to be building this sort of like properties dialog where it'll have collapsible categories that will correspond to, in my case, part number and material, right? And in each of these categories, I will have property like key value pairs corresponding to the value and the number of occurrences. So chassis 2, glass 1, steel 5, for example. And that's it. So now let's see if this works, since I tweaked the logic for this a little bit. So our app is still running, and since we've only modified the client-side assets, we don't really need to reload the server-side app. So let me go back, open the Dev Tools and reload my page. All right, so the model summary extension has been loaded. So now what will happen, again, if I click this model summary icon for the first time, it should create a new instance of the panel, right? And it should use the helper method to retrieve all the leaf nodes from this particular sports car model. And then it should retrieve the part number and material. I think I left it there, right? Yes. So it'll retrieve all the different values of the part number properties and the material properties for all the leaf nodes. And it'll build the histogram based on the results as it iterates the results returned from the get bulk properties method. And then we use the results from the histogram to populate the panel itself. So let's give it a try. And there we go. See, so these collapsible categories are defined by the third parameter to the add property method, prop, right? So prop is actually, in my case, is going to be the part number and material. And for each one of those, you can see that, okay, in case of material, all my objects, all my leaf nodes in the scene, there is 41 of them. All my 41 leaf objects have the material property set to generic. And of all those 41 objects, 4 of them have the part number set to rem2, and only 1 of them has the part number set to chassis, right? And only 1 of them has the part number set to motors. So you can see now that this is finally getting to, like, you know, bit deeper into like how you can start extracting, again, all the metadata extracted for your design by the model derivative service, or how you can navigate or traverse the hierarchy of your model, right, to find out if there are, you know, which are the group nodes, which are the leaf nodes that have no other children, etc. All right. And that would be it for the docking panel. And now we can move on to the second part of our session 3, and that is the preparation of the data for the dashboards that we're going to be building in session 4. All right. So for that, that's going to be this dashboard tutorial on the LearnForge website. We're going to start, we're not going to go in the exact order. We're going to start by the prepare data section in the tutorial. All right, so this basically explains the same thing we just did, right? In our model summary extension, how it's building the sort of histogram to say that, for example, for a property called category, we found these objects that had this category set to walls. So now, instead of simply storing a number, counting the occurrences of how many times this property was set to this value, we actually store the object IDs, and you'll understand why in the next session. It's going to give us some neat little functionality, user experience, if we remember the object IDs. Okay. So we're going to start by defining a dashboard panel JavaScript file. And we're going to create a subfolder in our JS folder where we keep all our client-side JavaScript assets, just to keep this slightly separate, a little better organized. So let me go back to my source code and create a new subfolder under JS called dashboard. All right, and in here, let me copy this code and explain what it does. Let's copy this code snippet and add it to a file in this new folder called dashboardpanel.js. Dashboardpanel.js. All right, so what we have here is a couple of helper classes that we're going to be using in the final session today to actually add the dashboards. So first of all, we'll have a dashboard panel, which is sort of like really just a a base class for all the specific, let's say, pie charts or bar charts that we're going to build later. The base class in itself is really only responsible for appending some kind of container div element to the specified parent. You can see that's what it's doing here, right? We're using jQuery again. This construct basically means selecting a jQuery object for whichever parent element we've specified as the first parameter to the load method. So we're trying to get a jQuery wrapper for that HTML element, and calling that append basically means we want to insert or append a little bit of HTML into it, right? So we're inserting another div element with our own ID and with our own, CSS class called dashboard panel. That's like the base functionality of this dashboard panel, so that we can add multiple of these into the dashboard, so that we can have multiple panels. And then we subclass the panel specifically for charts. So later on in session 4, we're going to be inserting again pie charts and bar charts. So here we overload the load method. Here it's where we call the parent version, right? But in this case, the load method will actually do a little bit more, right? So here, instead of only appending a div, in this case, we will also append a canvas inside the div container. And this is something, canvas is a typical HTML element that you would use for custom 2D or even 3D graphics. The viewer itself actually uses canvas to render all the 3D graphics and the drawings. And then we include some helper methods for generating colors for our charts later on. Okay. And now, so this is just for the UI aspect of things, of our dashboard application that we're going to implement in the 4th session. That's for the UI, but now we also need to implement the logic to, again, compute that kind of a summary, similar to what we did in our model summary extension, right? So we again need to implement some way of computing some sort of summary from our model. And that's something that is going to be encapsulated in this model data helper class. So you'll see that we're actually going to be using it, that the model data is going to be passed, an object of the model data class will be passed to our individual dashboard charts. And the model data itself then basically defines how the summary is computed, right? So we can see here very similar as we did earlier. We have the get all leaf components, right? So again, we are using the object tree from the viewer, and we're using the same enum no children method to get all the children, all the objects under our root, and we're checking if they are leaves, if they have no other children underneath them, and if they are leaves, we save them in a list, which is eventually returned to the callback function. Right, and in the init method, we, again, very similar logic as what we just built, right? We collect all the leaf nodes, and for each one of them, here you can see we're calling, again, viewer.getProperties. It's not the get bulk properties, right? So you could potentially tweak this as well to use that other more efficient method. What we do is for each of the IDs, we request their properties, and we iterate through all the properties. And again, we're building this histogram, right? So that's the underscore model data, where we're going to be just like the histogram we had in the previous extension. This is where this is going to be this one large object that will provide that will include properties representing the different property names, like part number, material, right? Or others in your case. And under each of these properties, it will keep another JavaScript object where every property will be a possible value, right? So for material, it could be, again, steel or glass or whatever. But now, instead of storing just the number of occurrences, as I was mentioning earlier, we're going to be storing a list of object IDs that actually have this property name set to this property value. So that's what we do here, right? That's That's everything that happens during the init phase. So when calling the init, the model data structure internally will basically be populated with the histogram summary, where again, for every property, we store the number of occurrences of different values. And here we actually are not filtering the property. You may have noticed here, right? Earlier, we were only asking for a specific property name, but here we're actually asking for all properties. We're iterating through all properties. So the histogram will contain all the different properties, all the different objects, all their different values. All right, and finally, the model data structure then provides a couple of helper methods just to quickly check, for example, if any object in our model has a specific property name, right? So we simply check by looking if the complete histogram object, if it contains a property with that particular name. And yeah, get labels and get count instances. This is something we're going to use later for the charts to actually say, for example, in the chart, if we want to show a pie chart showing the number of occurrences of different values for the material property, we will use the get labels method to find all the different values that were available for the material property, right? So maybe that was glass, steel, wood, whatever, right? So that's what we're going to return in this helper function, or helper method. And get count instances, this is just to show, just to get the number of objects that have, let's say, the material property set to wood. And IDs, get IDs, this is something we're going to use later for that little nifty trick where when we actually select one of the bars in the bar chart or one of the pie segments in a pie chart, we will actually use this helper get IDs method to isolate the corresponding objects in the viewer, right? So this is to show that you can actually have this interaction happen both ways. You can extract information from your model using your APIs and build charts, and then once there's some interaction with the charts, you can actually, connect it back to the viewer so that you have like this cross-referencing behavior. So when you click on something in the chart, or when you click on something in some table, HTML table, you can then highlight or hide or isolate objects in the viewer to really connect the two pieces of information. All right, so this is not something we're going to be able to test right now, just yet, right? This is just a preparation work for the dashboards that we're going to add in the final session today. All right, so with that, now it's again your turn to follow along. So feel free to experiment with the panel UI, right? So create your custom extension that will have its own property panel that you can show in the viewer and populate it with any kind of data you want, right? In our case, we're computing that histogram summary again. And then if you could try and follow the prepare data step of the dashboard tutorial, right? Because that's basically what we're going to need when we move on to session 4, when we start adding the actual charts to our dashboard. And we must not forget to actually bring in, again, the JavaScript code with our dashboard panel to the HTML when we meet here in 1 hour and 10 minutes. All right, so with that, good luck, and I'll see you back here again in roughly 1 hour and 10 minutes. Okay. Hello, everyone. Welcome back to session 4, to the final session of our day 3, working on customizing our viewer application and extracting information from our models to build dashboard app. While we give some time for questions, there was one in the Q&A asked regarding the internal SVF IDs versus the external IDs, and where people would really want to be able to, let's say, select a Revit element not by Dbid, but by the external, like in this case, a Revit GUID, right? How that could be done. And there is actually an important functionality available on the model class in the viewer that I would recommend that you check out. That method is called get external ID mapping. Again, it's on the model class, and it's a synchronous method again. So it returns, expects two parameters, a function that should be called in case of success and another function that should be called in case of an error. Now, let me show you how that works. So my sample app, my sample Forge application is still running, listening on port 3000. So what I'm going to do is I'm going to go to localhost 3000 and open the DevTools. Now let me show you. Okay, I've got my model loaded in the viewer, right? So now if I refer to viewer.model, this is actually the instance of that model class representing, in this case, my DWFX file, right? And again, if I wanted to hide something here, like maybe hide the roof of the car, I would need to use the internal SVF ID because all the viewer methods pretty much work with the DBIDs, right? So if I wanted to hide the roof, I'd have to say viewer.hide number 80, right? But again, someone asked a question in the Q&A, a very, very valid question, how we could go around actually hiding or selecting objects in the viewer programmatically by their external ID. Let me show you. All right. So there is, on the model object, like I said, there is a method called get external ID mapping, which is, again, an asynchronous method. So we want to just, let's say for now, we just ask the viewer to log it to the console. If it succeeds, or output an error message if it fails, too many hours. All right, so here's our map. This is basically one large object that maps all the external IDs. In case of Revit file, that's going to be the Revit UIDs, right? In my case, I'm working with this DWFX file. It's going to be these strange, I'm guessing they're like SolidWorks, maybe object IDs, and map them to the corresponding internal SVF IDs, right? So what I can do is, let's say I can define a global object called mapping, and I'm going to call this function one more time. When it receives the dictionary, let's say I can write dictionary, I'm going to save it into the mapping global object, right? So now in mapping, this is my dictionary mapping from external IDs to SVF IDs. All right. Now, if I look at the properties of, actually, I'm not going to see the external ID, right, for the roof, but I can find it by saying using the get properties. So let's say that somewhere in our database, let's say I have my MongoDB database or a SQL database where I store some additional information for the parts of my car here, right? And I'm storing that information under this external ID of the roof. So now, if I wanted to, let's say, select the roof by not the object ID, but the external ID, what I can say is I can basically just do mapping, right? So this way I can map from the external ID to the SVF ID and pass that along to the select method. And that will basically select our roof. All right. So I see no other questions. So I think we're ready to move to our final step, where we're going to adjust the layout of our HTML page a little bit. And we're going to add a couple of charts, bar charts and pie charts, again, showing some of the computed results, the histogram or the summary from all the elements in our model. All right. And that is a cue for me at demo time. All right, so going back to our dashboard tutorial on the Learn First website, we're now moving over to the adjust layout step. So here again, what we're going to do is instead of typing this in by hand, let me copy this snippet. That will be the content of our file called dashboard.js under the JS dashboard. Go back to my app and create a new dashboard.js file. And let's take a look at what we're doing here. So basically this at the top, the beginning of the file is yet another standard jQuery construct where we basically can get a jQuery wrapper for our entire HTML page for the document. And we're adding a function to be called when the page is ready, when it's fully parsed. And what we do inside here, we're actually adding one more event handler called, for the event called DOM node inserted. So basically what we're doing here, a little trick, we're using jQuery to handle a situation when certain HTML content is added to our page, right? And what we do is we try and see if the object that's been inserted has a CSS class on it called Orbit Gizmo. And I believe this is in place for basically checking when a viewer has been loaded, right? So we have a little piece of logic that we want to wait for, and we want to wait with executing this logic until after the viewer has been inserted into the page and until an actual model has been loaded, which is when the Orbit Gizmo class will be added into the viewer. This is a bit of a trick here. You may experiment with other lifecycle events of the viewer to maybe decide when you want to insert your dashboards. And then what happens is we create a new instance of our dashboard class. And this is basically the top level UI entity that will include all the different bar charts and pie charts inside it. So what we do here, you basically say, okay, we want to create a new dashboard next to our viewer, right? And we want to include two charts, one bar chart. And here, this is a class that we're going to define in a moment. And the parameter we're passing to the constructor is basically saying which property we want to show the chart for, right? The data for. So we're creating a bar chart and pie chart. And in my case, I'm going to try and show these charts showing the histograms of the different values available on the material property, right? So we can try and change this later. You know, in my case, in the WFX file, I've been trying to use the material property as well as the part number. And again, in your case, depending on the design files you're working with, you can try different property names. All right, so we're passing in two instances of our charts, right? We're going to receive these in the constructor, so our dashboard class. And here's basically what we do. We just store these these input chart panels in a local instance member variable, and we adjust the layout of our application, right? Only at that point the dashboard is initialized. And what we do to adjust the layout, we get all the children of the single row element that we have in our HTML, and let me just bring that up here. So just, if you remember, again, a row is one of the classes provided by the Bootstrap CSS framework that we're using to build the layout of our application, right? So these are the different CSS styles that you can apply to different HTML elements to build your responsive layout. Bootstrap has this row column system where you can have basically grids of different fragments of 12, right? So you can have like 1/12 column or 2/12 column with, that's what we're using here, right? To define one column that occupies 4/12 of an entire row, and another column that occupies 8/12 of an entire row. We only have one HTML element with the row class. So what we're doing, and this is the row that this is the rest of the page under our title header, right? So what we're doing in the dashboard.js file here in the adjust layout method, we're basically taking all the children that are inside that row. So right now, that's just two columns, right? One that's the sidebar, that where we keep the preview, and then the main column that is used to host the Forge Viewer instance. What we do is we remove these original classes that were scaling these two columns to 4/12 and 8/12 of the complete area of the entire row. And we are replacing these with a smaller fraction, as you can see here, right? So we're basically squeezing the sidebar to go from 4/12 to 2/12, and we are resizing the main div with the viewer to scale from 8/12 of the entire width to 7/12. And after that, we insert another div element, like a third column, right? And that's where we name it, we gave it the ID dashboard. That's where we're gonna insert our dashboard panels to. And that's actually what happens here in the load panels method. See, so we've inserted a custom div with our ID dashboard. And later on, when calling load panels, we're actually going to insert the individual panels that were passed to our constructor inside this div element. We empty it first, and then we start inserting individual panels into it. This load panels method is not called immediately in the constructor. This one is actually called in response to a viewer event called geometry loaded event. So what happens is that we can create the dashboard earlier, insert it into our HTML, but the charts, the individual panels or bar charts, pie charts, will actually not be inserted into the dashboard until the viewer emits this geometry loaded event. And this is an event that is called when basically all the geometry of a model is loaded. And that's pretty much it for the dashboard.js file. Again, we need to make sure to include it in our HTML, and I actually forgot to include the previous file as well. So let's go back to our index.html, and I believe we can probably insert these at the end of the head element. So we insert the dashboard.js file, and let me also use this opportunity to insert the dashboard panel. That's the data prep JavaScript logic we added in the previous session, right? Okay. And now, oh yes, we want to, if you may have noticed, there was one more special type of class, CSS class we used in the JavaScript code. Let me bring that up one more time here. We're basically using this jQuery logic. We removed the existing CSS classes and we added different ones, including this transition width. This is a custom CSS class that we define ourselves. And this is basically used to provide a CSS property to animate the transition from some width to some other width, so that the sidebar and the viewer, when we shrink them to make room for the dashboards, they don't jump to their new size immediately. They transition them over time, over 1 second specifically. So let me copy the CSS, the additional CSS rules for our dashboard, and we can simply add them, append them to the end of our main CSS. Or you can create a separate CSS file for dashboards. That would probably be a little bit cleaner. You can do that too. All right, so we're specifying again overflow for our main dashboard area. So if we get too many dashboards, instead of stretching the entire app and having the entire app scroll up and down, we will simply just show a scroll bar just for the chart container, and everything inside it will scroll. And the height will be specify exactly to be the 100% of the viewport height minus the 100 pixels, which is a little extra room we keep at the top for the navigation bar for the header. All right. Now we can move on to actually adding the charts. So now we're jumping over the prepare data step. That's something we handled in the previous session. And now we can finally start adding our bar charts and pie charts. Okay. Now for these, we use a third-party library, which is called chart.js. There are a couple of options. Well, you have actually quite a few options for generating charts on the web. Chart.js is a pretty nice one. There are others like eCharts from Apache, I believe. But here we're going to be using Chart.js. So what we need to do before we start building our own dashboard panels, we need to bring the dependencies for the Chart.js library. And we do that by adding a script element and a CSS, importing a CSS style sheet from the CDN, right? So many of these open source libraries typically offer their JavaScript and CSS files to be fetched from different CDNs, in this case, Cloudflare. So let's copy these two extra dependencies and add them to the top of the head element in our HTML, right? And again, just to make sure that when we call the chart.js functionality, and the chart class will actually be available. All right, now we can move on to building our first actual dashboard panel, and that's going to be the bar chart. So if we remember, we already prepared this helper class dashboard panel chart in session 3. That's basically, on its own, it's just responsible for allocating some real estate on the HTML page and creating some div element and canvas for hosting something, right? That's what the dashboard panel chart is doing. And when we subclass it into our bar chart class, we will basically leverage that canvas. You see here, we basically remember the ID of the canvas element on the object, on the class object. We're going to use this information to get a rendering context of the canvas and render into it. Because when we start using the chart.js library, the library actually needs you to provide some rendering context that it can render the charts to. Let me again copy this code snippet. And we're going to place it under the JS dashboard folder into a file called panel-bar-chart.js. It's called panel-bar-chart.js. All right, and again, all we do here is we just subclass our helper dashboard panel chart class, and we override the load method, right? So again, if we look back at the original implementation, the load method, what it does is it's responsible for processing the model data that's been passed to it. And it's responsible for adding a canvas to the HTML that eventually will be used by our chart to render the graphics into, right? And we store the canvas ID so that our subclass can actually know which of the canvases it should be rendering into. So this load method, we are now overriding. We try and call the original version of the load method. If it doesn't succeed, we return. Otherwise, we draw our chart, right? So when the canvas is ready, and if everything goes well, and we have some model data, actually something to show in the chart, this is the draw chart is the method where we actually create a new instance of that open source chart.js library. We create a new chart of the type bar, and here we specify the data to show, right? And here's where we're finally using some of the helper methods that we define on the model data class, right? So get labels will basically take a look at a specific property, like let's say material or prop name that we built in our summary, and it will see what were all the different values that were found for this property. So for material, it could be glass or steel or wood. So we're going to get a list of all these possible values, and we're going to use them as labels, right? So if you want to show the, let's say, occurrences of all the different material values, we want to show something like a bar chart showing wood, this many occurrences, right? And steel, this many occurrences, and glass, this many occurrences. And then for the actual data set, we're calculating the number of instances, right? So this is another helper method where for the specific property name, like material, we want to receive an array with numbers of how many times the different values for the material property appeared. So glass appeared, let's say, 2 times. I don't know, grass appeared 5 times, and plastic appeared 10 times. And we specify some visual properties like background, border color, or the line width, the border width. And a couple more Chart.js specific options that you'll find in the documentation for Chart.js itself, right? So here we basically say that, okay, we always want the y-axis to begin at 0, right? And we want to hide the legend. And when somebody clicks on one of the bars in the chart, we want to run some custom logic. And what we do here is we basically are reusing this get IDs helper method on the model data class. And we say, when somebody clicks on a specific bar that maybe that corresponds to the material property set to steel, we're going to use this get IDs helper method to get the object IDs of all the objects that have the material set to steel, let's say. And we're going to pass it into the viewer isolate function method to really show all the objects in the scene that actually have this property set to this value and hide everything else. All right, that's our bar chart. And again, we must remember to bring that into our HTML. The panel bar chart, I'm going to add it at the end. At the end of our head element. Now we can move over to the pie chart. It's going to be doing something very similar. So let's just copy the code and paste it into a panel pie chart JavaScript file under the dashboard folder. So we're going to call this one panel pie chart.js. All right, very similar, right? So the load method is pretty much the same. The draw chart, mainly the same as well. The only difference now is that when we're instantiating our new chart, instead of giving it a type bar, we're now setting the type to donut, right? We still use the same labels. We still use the same data set, right? Where the values we actually want to show are the numbers of instances when of how many objects have this certain property set to some specific value. And again, when we click on one of the pie or donut segments, we will basically just show these objects, isolate these objects in the viewer and hide everything else. All right. And again, we must not forget to bring the JavaScript file into our HTML. Panel pie chart. All right. That's pretty much it. So now let's see what happens. Our app is still running. And again, I haven't modified anything on the server side, so I don't need to restart it. I can just reload the page in the browser directly. Okay, so let's see. I open my sports car model. When it's loaded, yeah, only after when it's loaded, it should basically insert our dashboard element with 2 charts, right? If you remember, that's what we defined in the dashboard.js here. We'll basically say when the document is ready and when a viewer is inserted into the HTML tree, into the DOM, we built a new dashboard with two charts, a bar chart and a pie chart, both showing the already computed information of the summary, right, the histogram for the property called material. Now, in my case, for this car, I mean, every element here has the material set to generic, right? So this is basically, these charts are showing me that there are 41 objects, all having the material property set to generic. Now we can maybe try and see the part number maybe. So let's do this. For the bar chart, I'm gonna try and show all the statistics for the part number, and the pie chart I'm gonna leave basically displaying the summary. It's kind of boring for now, but that's okay for the material property. All right, so let's see. I'll reload my page. There we go. All right, so let me close the Dev Tools to get some more room. And you can see here that we're now getting slightly more interesting results, right? Showing that for the part number property, that there are, again, 4 objects that have 4 elements in our design that have the part number set to rim2, and 4 objects that have the part number set to disk 1. And then all the others or only occur once. Now let's try something. You know, we added the on-click event handler so that when we click on one of these bars, it should actually isolate those objects that have, in this case, the part number property set to rim2. Boom, right? Show everything, and we can try the disk one. Oh, it's interesting. I'm not sure why these have a part name set to disk, but I guess that's a different question for the creator of that sample file. All right, and then if I click on motors, this is also very interesting. So this is the motor. All right, not sure why, but you get the idea. Actually, let me try this. This is interesting. Yeah, okay. So for some reason, these 2 elements actually have the part number property set to motors. So I guess those are motors. All right. So that's it. That's our complete application, showing dashboards, computing different sorts of summaries from our objects metadata, and displaying the results in form of these interactive charts. And again, in your case, if you're working with a Revit file or IFC or in Banner, you may want to tweak these and use different property names, right? So some property names for which you think it would make sense to compute this sort of a histogram summary. Okay. And I believe that is it for our session 4, and that is it for today. Okay, so what will happen now is, again, give you some time to follow along and try and finish, wrap up this dashboard application yourself as well. And I'm gonna stay online for roughly another 30 minutes or so. I'm gonna stop the recording, but I'll be here monitoring the Q&A. So if you have any questions, if you run into any problems with these final steps, wrapping up your dashboard application, feel free to let me know, and I'll try and make sure that we can unblock you and make sure that you can actually complete your Forge app for today. All right, so that'll be your time for questions. Now, the final topic that will be covered by my colleagues tomorrow is going to focus on the Forge Design Automation Service. And for those of you who haven't heard of it, the Forge Design Automation Service is basically a way for you to run custom logic, custom plugins for either AutoCAD, Inventor, Revit, or 3ds Max remotely on Forge servers. So if you have some kind of a custom AutoCAD plugin or some custom Inventor or Revit plugin that you would like to run maybe on Forge servers in like an automated pipeline where maybe you would like to, I don't know, maybe make modifications to a Revit design based on some input parameters, or to maybe generate a new inventor assembly based on certain input parameters to build your own sort of configurator, right? The Forge Design Automation service would be a really good tool for that. So my colleagues will guide you through the design automation focused tutorial from the Learn for website tomorrow. And again, that track will be available in parallel for both .NET and Node.js languages. All right. Now, after this event, if you're interested in getting some more technical support, please know that we are very active on Stack Overflow. So if you ask any question with one of these tags, we're going to get a notification in our internal ticketing system. The same thing happens if you send an email to the official forge.help@autodesk.com email address. You'll also find it on the portal. If you need to get the actual links, you can simply head over to the forge.autodesk.com, the official developer portal, and look at the support section. And in the get help, here's where basically you find all the questions, right? All the options, sorry. You can either search for existing questions on Stack Overflow, or you can just reach out to us directly through a form or through email. And with that, I thank you for joining me today, for pushing through the entire course here. Today it was a little more work, a little more coding, more complex, but I hope that we've been able to show some of the possibilities of the Forge platform and what you could potentially ignite some ideas in your heads as to what you could potentially build with the platform as well. All right, so thank you very much for joining me today. Let me stop the recording.